Hi, everyone. Good morning, good afternoon, good evening, wherever you are. Thank you very much for joining today and waiting. If you're new to our digital events, my name is Sonia Jones, and I'm an event manager at Capture 3D. It's an absolute delight to welcome every one of you here today. We actually expecting about 100 people today, and this is going to be our sixth training session since last May. So our team has trained so far over 700 users on GOM software, and we've been hosting this complimentary training every month, every other month due to a popular demand. And also we have decided to make this as a periodic training. So now we'll host the same complimentary GOM Inspect training once a quarter starting from this year. And if you enjoy our training and the takeaway a lot, we hope you will, which we hope you will do, and please do share this with your colleagues and friends, whoever you think may benefit from it. All right. So I still see people logging in. Welcome everyone to our GOM Inspect training, and we really appreciate you joining us or tuning in the next 3 days. There will be an hour Q&A session, or as we call it, open office at the end of a 2-hour training every day. So yeah, we have a lot to cover today and hope you take away a lot and learn the tools to easily inspect your parts. There you go. I'm just going to go over the background of our company real quick and make a few announcements before I give it over to our instructors. So bear with me, okay? First, let's take a look at our company and what we are about. Capture 3D is the US partner for GOM's 3D measurement solutions, and we have been partnered with GOM for about 22 years now. We are headquartered in Santa Ana, California, with locations in Connecticut, Michigan, North Carolina, and Washington. I'm based out of our California office, and our instructors are from our Michigan office, but they are working from home today or this week, making this training completely virtual and remote training. We have a team of about 100 team members and growing, and over 65% of our company is comprised of engineers, and we do provide GOM's technology and software. So just to give you an idea of who GOM is, they are our partner and the manufacturer of our systems and are based out of our Braunschweig, Germany. GOM was privately owned up until 2 years ago when it was acquired by Zeiss. So now we are all part of the Zeiss company. Okay, a lot of those joining us for the next few days are our current customers, and we are really happy to have you participate. Many of you are already familiar with our 3D scanning solutions and technology or the lineup of the system, but I did want to make a quick note that we launched 2 new products. The first one is ATOS Q, which is our brand new portable, compact, and high resolution scanner for small to medium-sized parts. Another great compact system is our new GOM Scan Cobot, which is a collaborative robot for 3D scanning. It's designed for an easy entry into the world of automation. This mobile system is basically combines a high-resolution optical 3D scanner, either ATOS Q or Core, with a collaborative robot and the motorized rotation cable. So the price point is really great, and actually we did have a virtual event for this Scan Cobot last month, and if you're interested in watching the launch event, you can do so by scanning the QR code shown here or click the link launch event. Okay, so for those that are interested in our technology, our new products, or we offer complimentary demonstrations or POC, or what we call it, proof of concept, whether online or in person. So please feel free to contact us at info@capture3d.com to learn more about it. Okay, so one more announcement that I would like to make is we host industry and application-specific webinars every other month. And it's a 45-minute webinar with 15-minute Q&A. We just did one last month on, actually this month, early this month, on medical industry, and the next one up is going to be on additive manufacturing. Here's a list of those that are planned. So now additive manufacturing and metal forming, and these are the webinars that are planned for the remainder of the year. So in these webinars, we'll highlight how the 3D scanning technology is throughout all stages of part engineering from design to production, what trends we are seeing, what innovation are happening, and we also go over the most innovative and useful software features that each industry or process can benefit from. So these are really informative and technical webinars we put together. So I recommend that you guys check it out. All right. Also, we do have some great digital resources available on our website. If you'd like to watch our previous webinars, training, tutorials, and such, please visit our website. We are continuously working on adding more digital resources for our users, and some of them can be found on our YouTube channel as well. And if you know any of our Capture 3D engineers or our engineering team, you'll see many familiar faces in our digital engineering tutorials, including our instructors for the GOM-INSPEC training. So if you go, so where you can find those digital resources is that you will want to go to our website, go to Knowledge Center, and everything will be available under blogs. So like I said, we regularly update our digital resources. So if you have any questions, please feel free to reach out to us through our live chat on our webpage or email us at any time, okay? So going back to our main topic, what exactly is GOM-INSPEC Suite? As you all know, since you have downloaded the software already, it's the software that's offered at no cost, but it's very powerful viewing tool for sharing reports, inspection, and projects within your organization. Basically, anyone can download it and share the reports and inspection with others. You can also use the data from other 3D measurement systems or technologies such as laser scanners, CT, and other structured light systems. There are other paid software applications available within the GOM-INSPEC suite, but you can see here that in the chart that pretty much, for the most part, you can inspect your part with the free software. And our instructors will show you how you can do so. Okay. Right. So there are actually countless features available in both free and pro software versions. And here's a really short list of some of the features that you can do or achieve with GOM software. And please feel free to ask your instructors about any of these features listed here, or simply send us an email at info@3d.com. All right, so I'd like to remind you all that those who attend all 3D, all 3 training days will receive a digital copy of Certificate of Completion, which will be emailed to you by next week. If you didn't fill out our training registration form on our website, we may not have your information so to generate the certificate, right? So please email at training@capture3d.com and provide us with your information so we can make sure you get your certificate. All right, without further ado, I'd like to introduce your instructors for the next 3 days. We have Maddie as your main instructor who will be presenting during the first 2 hours every day. She's been with us for a year and a half and been training and supporting our users on various types of. We also have David as your second instructor, and he's been in metrology for 11 years and 4.5 years with Capture 3D. David will be monitoring the Q&A and answer your questions while Maddie is presenting. Both our instructors, along with Wade, who is our lead application engineer, will be able to answer all of your questions during the Q&A session. With that, I'd like to give it over to David so he can give you a rundown of some of the WebEx features.
Hello, everyone. David, I'm an applications engineer here at Capture 3D in Michigan. Like Sonia mentioned, I'll be handling the questions and the behind the scenes. So if you have a question, you can use the Q&A spot in the chat. Send your questions there. I can answer it directly to you. If you want to talk amongst yourselves, you can send a question to all panelists. And then I might ask you, hey, that's a really good question. Do you mind sending that to all panelists? And we'll answer that at the end and maybe even give you a little demonstration. But don't hesitate to ask questions. I'm here to answer them. And like I said, I'm behind the scenes. One thing I want to note though, you'll see a return button at the top of your screen. If you don't see that, just take your mouse to the very top of your screen and you might see a window scroll down, and then you'll see the return and you have all your chat options right in there.
Okay, hello everybody. My name is Maddie. Hopefully you all can hear me okay. I'm going to be your instructor for the next 3 days for our free GoMinspect training course. So really quickly, just to lay out the contents of the course. So far we've kind of covered just 3D metrology in general, applications, and then I'm going to dive into a little intro we're going to give on 3D scanning. Since this is just the GoMinspect course, we're going to mainly focus on the software. So it's kind of laid out here what all the topics being covered are going to be. So like I mentioned, before we get started, I'm just going to cover really quick our ATOS process because we do cover all steps from measurement to evaluation to inspection. Starting with step 1, which is measurement, collecting that data in which we're going to inspect. So a quick ATOS scanning demonstration. So for this, we have our ATOS Q, like Sonia mentioned, set up on a tripod, which is scanning our GoMinspect block. So as you can see, it's projecting this blue light and fringe pattern onto the part. So it's using that pattern to collect all those unique geometries, and then it's using the reference points you can see on the part to stitch those scans together. So in the software, you're going to see something like this. You're going to be able to easily see where you've captured, where you're still missing data. And once you have full coverage of your part and you're happy with all your data collection, you're going to be able to polygonize that right in the software. So that's going to be the next thing it shows. Okay. Cool. So just to kind of cover what we just saw, our 3D scanners do use what we call the triple scan principle, and this is our 3-in-1 sensor concept. So kind of demonstrated here by this red figurative color and the blue. Basically, the data collected by the left camera and the right camera are separate, and that's how we're able to get full coverage of deeper or unique shapes as shown here, right? So that camera, this left sensor camera is able to pick up this inner left wall, and the right camera is able to pick up that inner right wall, getting you full coverage. We are offering other additional training material, both on our YouTube channel, like Sonia mentioned, or you can go to the GOM Training Center, which is directly from our distributor. So this is going to be a really great place to get lots of technical information as well. So if you're wondering where I'm going to be pulling from for this whole class, you're going to have access to this training class material folder by clicking this link or copying it and typing that in your search or your URL. So basically, I'm going to have all the exercise files that are required to follow along with me, as well as the resulted complete projects, some additional handouts, and then keep in mind this folder number 4. This is going to be updated daily for you guys. So as we present and we record each of these days, those are going to be uploaded. So you're going to be able to have this data for in the future and be able to go back and reference it. So we do release a new software every year. We're currently on software 2020, which was released in August 17th of last year. Another thing you're going to need to be able to participate in this training is your GOM ID. So hopefully you've gotten this all set up before we started. But basically, this is going to be your unique GOM login, and this is going to be how you can access the GOM Training Center, the Software Center, as well as download things like packages off of the GOM Connect website. So for today, you're going to see when we're in the software, there's going to be this little icon that looks like this. You're going to be able to go down in there and log in super easily. So today we're going to be covering what you see on the left, which is this GOM Inspect suite. So something that you guys may have seen in the past are these professional versions of the software, like Atos Professional, TriTop, Pontos, everything like that. So those are going to be our softwares that require our license to be able to run them. Today we're going to be covering our free version of the software. We have two of those. We have both GOM Inspect Lite and GOM Inspect Suite, which we're going to be covering today. So GOM Inspect Suite, like I mentioned, we're going to be covering in this 3-day training class. That can incorporate all your different GOM Inspect packages. Some of these you may need your dongle or your license to be able to run, but the idea is that the GOM Inspect Suite encapsulates all of the prior packages, which would have had to have been individually installed. So whatever your license requires or holds, those are going to be all stored within your GOM Inspect Suite. But like I mentioned, you do not need a license to be able to run the free version of GOM Inspect Suite. So what is GOM Inspect? So GOM Inspect is our free inspection software, which you can analyze your 3D scan data collected from one of our Atos scanners. It's entirely free to use, and the results can be shared amongst your departments. There's just some very minimum system requirements here to be able to run it, which are listed. These are just your main computer requirements. So kind of like I mentioned before, the license is separate from the acquisition driver. So for your inspection, like we're going to be doing today, that's going to be free. But for your scanning license, that's going to require your external license. So some of the sensors that are supported in our GOM Inspect suite are our Core, Compact Scan, and Q. Unfortunately, the capsule, the 5, 5X, and 5 airfoil are going to require the professional version of the software. Also, we want to cover our improvements from 2019 to 2020. There's been some changes, some great new options for you guys. You're going to be able to see if you're working in our VMR or if you have a scan box, that now we have all these new options for measurement positions in VMR. We can create multiple part inspections, just like we could in 2020, but now or 2019, sorry. But now in 2020, you're going to be able to separate fixtures out into multi-parts. We've improved fine alignments. Go down. We have adaptive polygonization, so you guys are going to be able to choose areas of your part that you want higher or lower resolution. We have gray value feature improvements, and we also have a lot of improvements in the aerospace inspection, such as our airfoil eye inspections and UDIPs. And these are all kind of more advanced topics, but something we want to cover really quickly. Awesome. So now let's dive into the GOM Inspect software. So when you're opening up your GOM Inspect suite, you're going to see a start screen that looks something like this. It's going to have these 6 different cells. So to be able to start a new project, open a previous project, you're going to be able to download sample data off of GOM, store project templates, access recently used projects, as well as access the GOM community. So once you click that new project, it's going to bring you into the inspection workspace, which is annotated by this orange bar, as you can see at the top. And in this inspection workspace, you're going to have a lot of very powerful tools. So I'm going to dive into those in a minute when I open up the software. Some key things to notice is at the top right, help is available with a search bar that works similarly to Google. You can type in any questions you have there. If you're looking for a more specific help on a function, if you're in a dialog box in anything in the software, you're going to notice this question mark. And if you click that, it will take you directly to the help tab that's corresponded to that dialog. So just to quickly lay out the interface, like I mentioned, I am going to dive into the software right after this, and we're going to run through all of this together. And you're going to be able to have this to access as well for the future. But just working, with the workspace drop downs, becoming familiar with all of our menus, the status bar, all the different layouts within the software and how you can edit those. So like I said, I'm going to show you that in just a moment. Some really important shortcuts within the software. So some of the most common ones that you're going to hear me reference today is E to show an element exclusively, I to show an element or to hide an element, V to make an element visible, and then you're also going to see me dragging and dropping a lot out into the software. That's another way to show an element exclusively. Cool. So now we're going to dive into the live demonstration. Okay, so opening up our GOM Inspect suite, yours should look just like mine. Like I mentioned, you have these 6 cells here to choose between. This project templates, that's going to require the professional version. We are going to do a small demo on the professional version at the end of day 3. For now, I'm just going to go ahead and click New Project. And that's going to automatically bring me into the inspection workspace in the software. So dropping down this menu here, if I go back to start, you'll see that brings me right back to the start screen we started at, which is shown or displayed by red. Going back into the inspection workspace, the second one down, the third is going to be a reporting workspace, which is purple. And then the fourth is your mesh editing. So as you notice, these main menu drop downs are static. These do not change from workspace to workspace. However, your menu options that are in the color band will change. So if you ever are looking for something and you can't find it, just check which workspace you're in and make sure that you're in the same one that I'm in. So something that's really helpful is the status bar, which kind of shows you the health of your project. This will also give you hints and tips on what you can do to accomplish further inspections. We have the Explorer here, which is going to contain all the parts of our project. Our Sub-Explorer, which you can move these around and change them or add them back, but basically the relates to, required for, and depends on. And these are going to change depending on what you have clicked in your Explorer. Going over to the right, there's that help search bar that I mentioned before. So you can type in anything you may have a question about here. Like if I just type, just for example, A, right, it gives me suggestions of things that I might be having a question about. Or let's say I'm in operations, alignment, and let's open up maybe an RPS alignment, and I'm confused about this alignment. I can click the question mark right in here, and that's going to open up, sorry, I put it to my other screen. That's going to open up that direct help menu and give you any information you might need to be able to complete an RPS alignment. Down at the bottom, these are going to be our selection tools. This is how we select our data, whether it be CAD or mesh. And this is also, you can see most of them are grayed out. That's just because I don't have any data to select currently in my project. These are able to be changed. You can see I can grab an icon and I can throw it in the trash can. I can also grab anything that I find that I use commonly, such as maybe a fitting cylinder, and I can drag that into my toolbar as well. So this is completely customizable to you. If this is hidden for you, just check that this little 2 arrows is extended so that that's available. Similarly over here, if I hover my mouse to the right, you'll see I see those same arrows. If I click those, that opens me the Properties tab. And there's going to be a Properties tab for whatever I have selected in my Explorer, which is nothing at the moment. Last thing I quickly want to cover is the coordinate cube at the bottom here. So this is going to be a great option to be able to square up your view in a specific direction, as well as get nice isometric views for reporting. And if you ever lose your part, remember that this reset zoom button at the bottom here is a great tool to be able to snap your part back into the center of your 3D view. So to cover some of the mouse functions in the 3D view, holding that left mouse button, that's how you're going to be able to rotate your part. Holding that middle scroll mouse wheel, that will hold your view but allow you to move your part around the screen. Scrolling the middle mouse wheel allows you to zoom in or zoom out. And then clicking the right mouse button is going to open up selection menus. So like I mentioned, you have this 3D coordinate cube here, which is going to allow you to toggle between your views by selecting this box here. That will switch you from your cube to a rotational view about the X, Y, or Z axis. And these are all here just for you to be able to get nice, clean, squared up views on your part. Okay. Awesome. So we're going to dive back into the software now, and I'm going to cover importing into your projects, 3D selections, and some mesh editing. So opening back up my software, and then I'm going to be accessing that training folder that I mentioned before. So by clicking that link that was on the slide we previously covered, you're going to have access to these 4 folders. Today, I'm just going to be using this folder number 1. I'm going to grab some scan data in here, and I'm going to drag and drop that part, oops, sorry, into my, I have it downloaded on my desktop here. Okay, awesome. So dragging and dropping, you're going to see that import file, and you're going to want to select add as new part. Another option for this is going to be your basic file import, and then this will open up just your documents in your File Explorer. So now that we have our mesh in our project, we can practice with our mouse functions. So I'm going to click my left mouse button to be able to change that view here. If I hold the middle mouse wheel, that keeps my view, but allows me to pan my part around the screen, scrolling to zoom in and out, and then that right mouse button opens up a selection menu. Okay, now let's play around with some of our selection on mesh options. like a plane base. If I click this and then select on my mesh, you're going to see it will grab all my data that appears to make a planar surface. Some of the important ones here is a deselect, a select all, or a invert selection. So switching here now to our mesh editing workspace. And we're going to cover just some of the basic functions here. So working left to right, if I click close holes, I have the option to do that interactively. And if I look at the top left corner here, you'll see there's a small patch of data that I did not collect while scanning. So following the suggested mouse functions here, it says use control left mouse button to click a boundary. Click that there. You'll see it's going to show me a preview of filling that hole. And I can choose how much of the neighborhood data I want it to delete. Once I'm happy, I can click apply. And I can close out that function. Okay, something else we can do is our, smooth mesh. So here you're going to see that you're able to, actually before I do this, I'm going to go back into my inspection workspace. I'm going to drop down that mesh here. I'm going to come over to my properties tab. And under display, we have the ability to turn on that mesh structure. So zooming all the way in, everywhere that you see a triangle corner, that's basically a point of data that your ATOS scanner collected. The polygonization process is what triangulates all those points together and creates this surface mesh in which we can inspect on. So with that turned on, I'm going to go back into the mesh editing workspace, and we're going to play around with this smooth mesh function. So selecting an area, if I just say select all, you'll see this area here gives you a preview. And as I increase this tolerance, here, the software is going to update those triangulations between the points to make them smaller or greater. Sorry, it's updating here. And this is going to be a great function for you if you want to be able to download your, export your mesh as a smaller file in the software. So if I go ahead and click apply, and then close. Okay, diving back into the inspection workspace. I'm going to turn that mesh structure back off. Okay. I'm going to show you another place that you can find some of these selection tools. So if you go under Edit, Selection in 3D, and then geometry-based selections, you're going to have a full list here. So some of these might be interesting or important to you. And again, if there's one that you find that you're using more often, you can just drag that down into your toolbar here. Another great way to do selections is the select through surface. So again, paying attention to our selection box, clicking left mouse button to define an area. So if I just make a click, it will drag a straight line from that last click selection, and then holding right mouse button and then clicking this plus, we have the ability now to add that area as selection. As you can see here. Similarly, we can do the same thing, but with deselection. So I'll do the same thing in this area. I'll hold down that right mouse button. I'll drag over to the minus, and that will deselect that data. And if you want to remove all of the selections, we can just go ahead and click deselect all. So difference between through surface and on surface. If I drag my part, let's say just like to the side, and I use this through surface here, you'll see that collected data all the way through my part. If you're interested in just collecting data on a surface, you're going to want to use Select on Surface. And as you can see, it only selects to that first surface layer of the mesh. Okay. So as you saw, I imported the mesh by dragging and dropping, but you also have the option to do File, Import. Some of the selection tools I used, which these are mainly used to do our local best fit alignment, which we're going to cover in this training. So the mesh needs to be viewed just exclusively, which is all we had in our project. And then I used our selection through mesh and on mesh. This select patch is a great tool for when working with CAD, because obviously your CAD will have patches to select. But yes, there's a lot of selection tools in the software. Most of them are found in this 3D toolbar here. Again, using that right mouse button to click for more selection tools. So here's a list of all of the selection tools in the software. So there's definitely going to be something for you to work with to make your inspections match. So kind of like you saw me do, we use that plane-based selection, which grabbed data on the surface of the part that matched plane geometry. So these are found in Edit, Selection in 3D, geometry-based selections, and there's a full list of them here. And remember, instructions will always be given to you at the bottom of the screen, and that's going to tell you what mouse functions are required to make that selection. In the mesh editing workspace, you can fill holes, thin mesh, refine and repair, and more. So there are several functions in the software. So as you saw me do, we filled that mesh. We found that hole at the top left of the part, and we filled in that top corner. So we did this interactively. You also have the option to do automatically and search by hole size. And the software will run through the entire part and fill through. So with the automatic, that could be a great option if you're trying to create a watertight mesh, maybe for reverse engineering. But as you saw, we just did interactive, and we were able to then play around with deleting the nearby neighborhood of the triangulated data. Okay, so thinning mesh, again, thinning mesh is used when a file size is too big. So first we displayed the mesh structure, and that way we could see exactly what the software was thinning. Okay, so by applying that surface tolerance here, you'll get that view of exactly how thin it's going to make the mesh, or how big of triangles it's going to display. Okay, cool. So I think we're a little bit ahead of schedule here. So David, would you be able to let me know if everyone is doing okay, or if anyone has any questions?
Yeah, so far so good. No questions that need to be asked out loud, really.
Right. So we're going to have that Q&A session at the end of the training today. So yeah, so it seems like we have some Q&A questions coming up in there. But for now, we're going to go ahead and take a quick 10-minute break. So yeah, I'll meet you guys back here in 10 minutes. Okay, welcome back, everybody. Cool. So now that we've kind of just gone through like a basic look into the software, let's continue on into some more inspection. So I'm going to bring back that project we were working with, and let's bring in some CAD. So again, from that same folder we were working with before, except now going under the nominal folder. Again, I'm going to drag and drop in that CAD file. Okay, no problem. I'm just going to start again, bringing in that mesh as a new part. Okay, and then going back and bringing in that CAD. Okay, cool. Here we go. Sorry about the difficulties there. So now it's going to give you the option here to add to part. So since we aren't working in the professional version, it doesn't allow you to have part projects, unfortunately, but that's no problem. We're just going to add it in and say, okay. Did I bring it in two times? I'm sorry, everyone. One moment. Back into the mesh. Add to part. There we go. I got it all mixed up. No problem. Okay, so we have our mesh now displayed here, which you can tell it's a mesh, right? Because it's a continued surface here. And then we have our CAD, which is defined by our patches. And now something else you'll notice is if I open up my Explorer, we now have the CAD here, which is displayed by blue, and the mesh, which is green. So pretty much everything in the software that you're going to notice is going to have either a blue or a green icon next to it. So from here, we're going to create an alignment between our two parts. So when we brought our CAD in, that inspection coordinate system that the CAD is built in is also brought in. We can turn this off by clicking the I here or by clicking F7, I believe it is. Oh, wait, no, not F7, sorry, no. Sorry, you just have to click the I there. Okay, now using our alignment drop-down menu, which is right here, I'm going to use this first menu, which is pre-alignment. So the drop-down menu for alignments is another thing that's a little dynamic. It will kind of change around. You might not always see the same ones. The software is going to suggest what it thinks you might need. So we're going to get this automatic pre-alignment, which is going to be displayed or previewed here. And it's going to give you a deviation as well. So if those two parts didn't stitch and align right away for you, no problem. There's a few things we can do. We can play around with the search time between the parts. So depending on how symmetric or maybe your part has minimal geometries, you might want to play around with these search times. Another option is to do an additional help point. So you can select a point on your CAD and on your mesh, and it will use those points to kind of locate like maybe a corner to stitch together and then align the rest for you that way. But once you're happy with your alignment, you can go ahead and click OK. Looks great. And then you'll see here in the left, again, now we have our alignment drop down, and you can see the alignments here, which bolded means that it's your current alignment. Cool. So now that we have our mesh and our CAD aligned, we can get into inspecting. So starting with this left icon, if I hover over it, you'll see it says surface comparison. And if I drop this down, I have two options. I have a surface comparison on CAD or surface comparison on actual. So on CAD is going to just make a copy of my CAD to display this color map deviation. And on actual, they'll do the same, but it'll just make a copy on my actual. So if I click on CAD, some things we're going to want to play around with here. First, by turning our mesh off, you're going to get that full coverage of that color on your part. This max search distance, how far apart are your your CAD and your mesh currently, right? So right now, since we have a pretty good alignment going, nothing, the surface to surface isn't too far away, but we can edit this max search distance. If you're noticing that parts of your CAD aren't coming in, we can also set a tolerance here as well. And once we're happy with our surface comparison, we can go ahead and click OK. I can square my part up nice here. So now let's play around with the legends. So anything in the software, any inspection that requires this color mapping, a legend is automatically going to show up on the right side of your screen. And the legends can be independent of each other, but if you want all of your inspections to be able to be visible at one time, you're just going to want to make sure that the legends match. So by clicking right click here, I'm going to turn on this show histogram, which is a really great tool when trying to determine what you should set your max and min legend numbers to be. So as you can see on here, most of my color range is being shown between this positive 0.4 and negative 0.4 millimeters. So by clicking this upper limit, I can actually set that to maybe something like 0.5. And I can close this bracket here, which will lock my upper and lower limits together. And then just go ahead and click off of that. And you'll see now I'm kind of getting this display of more color range, right? Specifically, this isn't changing what the actual value is. It's just changing how it's being displayed on the right. So something you might notice here is that we're getting kind of a lot of color variation on this M. So this is telling us that our mesh to CAD seems to be deviating greater on this M than maybe other places around the part. So something we can do to test this, determine if maybe this is because of the actual form of the M, or maybe it's because of the position on the M when it was assembled. Perhaps it was assembled incorrectly. So I'm going to grab my mesh. Remember, I can make my mesh exclusive by selecting E or by dragging and dropping out into my 3D view. And my legend is now gone as well because I no longer am displaying anything with a color map. So grabbing data on just that M using our selection tools that I kind of briefly showed you before. So starting by turning my part to the side like this, I'm going to use that select through surface. I'm going to click just that M. Remember, I don't want to grab that data on the bottom planar surface because that won't tell me if this M is positioned correctly. But we obviously don't want to include this upper cylinder. So I'm going to do my same selection through. This time I'm going to move over to deselect. And now that I have just my M data selected, I'm going to drop down my menu option. I'm going to create a new alignment. And this time you can see now it's showing me main alignments because I already have an initial alignment. All of your main alignments are going to require an initial alignment prior to being able to use them. So clicking this local best fit, you'll see that I'm going to get a deviation again. You're going to get a max search distance again. And then once we're happy with that alignment to that M data that we've collected, I can go ahead and click OK. So now something cool we can do is turn on that surface comparison, as you can see here. And now in that local best fit alignment, you'll see the M is actually showing little to no deviation, meaning that the M form is okay, and it was actually just the position of the M. So again, I can toggle between my alignments as so, switching back to pre-alignment. You can kind of see how they differ here. All right, so basic functions and importing. We brought in our CAD by dragging and dropping, but again, you have that ability to file import and then adjusting the parameters here. So something I didn't do, but that's important, is it's going to automatically put this medium mesh resolution on the CAD. So it's basically going to turn your CAD kind of almost into a mesh, if that makes sense. That's how we do our inspections. So if you are working with a project and you're noticing that you're seeing really long loading times, you can try turning that to a low resolution for the CAD, or vice versa if you want a higher mesh resolution because maybe your CAD has really detailed or intricate parts, you can do that as well. So this is something that people often ask. So I would suggest if this is something that's important to you, just save this presentation so you can access this later. But just some CAD formats that are compatible with the software. Right here, you're looking on what's compatible with the free version. So what I've been using has been just a step file. But if you have the professional version, you see that it opens up a lot of options with CAD formats. So again, the software is accessible to many types of CAD formats. So now that we have some inspections, you'll be able to see in our Explorer that they get grouped in pretty much nominal categories and actual categories, which are always going to be displayed to you by those colors. Green, which is going to be for actual, and blue, which is going to be for nominal. And then you're also going to have a separate inspection category as well. So when everything gets brought into the software, the CAD stays in its designated coordinate system, and the mesh just kind of floats around in space, needs to be aligned to it. So using our basic alignment dropdown, I aligned the mesh to the CAD using our pre-alignment. Your pre-alignment is just an overall best fit. We always start with a pre-alignment to get our data sets close to each other so that we can move on with more intricate inspections. Once we have our pre-alignment open, you're going to see the dialog box gets almost automatically filled out for you. It locates that CAD and the mesh. The search time, like I mentioned, is short. It doesn't give you the option to do the nominal or actual help point, and then it displays that deviation for you as well. So remember, this is never going to be perfect. No actual manufactured part is ever perfect, so don't worry about this deviation number here. But it is a really good way to check, right? If you had a deviation number that was just exceptionally too high, you might go back, play around with help points, and just pay attention to the preview too, that everything looks correct before you click OK. Okay, creating that surface comparison or color map like you saw me do. I chose a surface comparison on CAD, which generates the surface comparison on just a copy of the CAD, so it keeps all those patch lines for you. And adjusting max distance, max search distance if required. Again, most of this is automatically kind of filled out. And then once you're happy with your inputs, you go ahead and click OK. So that legend is going to show up on the right side of the software, and you're going to be able to edit the upper and lower limits. You can either have these be the same or independent by playing around with this bracket locking icon. And there's so many more options as well with legends that we're going to get into later. So something that I didn't show is that you can actually change that legend type to a tolerance legend. Just leaving it on this basic GOM 3 color, you'll get that fail, passing, and warning tolerance zone. So that's just going to show you what elements of your part are within or without of tolerance. So now, playing out along with some other alignments, we have our local best fit alignment. So this is going to allow you to specify what data is being used. So the pre-alignment is a generic, collects all the data and best fits it the best it can, right? But with our local best fit, we can actually choose on the mesh where we want to align. So like I did, I selected on the M and then played around with the, again, max search distance until you're happy. And remember, if you open up this dialog first before you have made any data point selections on the mesh, no problem. The software will just prompt you to please select an area on the actual data. So again, it tells you what is required to be able to fill out a dialog box before so that you can click OK. Great, cool. So just continuing along, we're just going to get into some more inspections in the workspace. Okay, so we've made our surface comparison. So from here, let's play around with an inspection section. So I'm going to turn off my surface comparison. I personally, when I'm building things in the software, I like to work on my CAD exclusively. It just keeps things really clean and easy to work with, of course, unless it's requiring you to select on the mesh. So using this drop down here, I can create an inspection section. Again, we're going to do this on CAD, which just means it's just going to display it on a cut section of the CAD. So you'll see I'm getting an error here. We need to tell it where we want to cut this section through. So as my reference plane, a good option is to select maybe a plane in the X direction. And then from there, we can play around with the position. So where is this being cut? We can move this millimeter amount to cut pretty much anywhere along the CAD. You have your max search distance here as well, and then you're able to apply a tolerance in this also. So once we're happy with all of those selections, we can click Create and Close. And I can click E, and that's going to just show that exclusively for me. Squaring it up here. And if you're ever wondering where those grid lines are, if you don't like them, you can click F7, and that will toggle the view of those grid lines. Some companies prefer it, others don't. So again, playing around with our legends here, we can edit this if we wanted. But let's say you like the color map, you like the visualization of it, but you want discrete values. We can do this really easily in the software. There's two ways. Using this deviation labels, it's a little icon that looks like this. So the first option is to just click deviation label. The software is going to tell you, Control left mouse click to create an element. So if I hold Control and then hover over a part, you'll see I'm going to get a display of what that value is going to be. And if I click my left mouse button, that actually places that deviation label for me. That's a great option. Another option is a equidistant deviation label. So we want to make sure, again, we have our inspection section selected. And then I did that just by clicking the check select all. And then playing around with this point distance here. As we increase this distance, you'll see I'll have less deviation labels because this is the distance from one to the next, creating and closing that. And then you'll see we have some error deviation labels at the bottom. Is not a problem. That's just because we don't physically have scan data on the bottom of our part. So there's nothing for it to inspect. So to get rid of those, there's a few things we can do. Something I might suggest is using the status bar. So going into project guide and the ones you'll see the deviation labels that don't appear, I can select it. I can hold shift, select them all, and I can just go ahead and click delete and delete them out of my project. And then once I did that, the status of my project is now back to 100% green. So that's a really great tool within the software. Now let's do our final color map inspection, which is going to be our material thickness. So if I grab, again, my CAD, I'm going to drag it out. I'm going to show it exclusively. We're going to construct a material thickness on this O on the GOM block. So again, that thickness is going to be the value from surface to surface. You want to make sure you're selecting somewhere that you know you have scan data on both sides of the surface of the part. So going into construct, surface, material thickness. It's going to give me this dialog box here. And again, it's prompting me, please select points in the 3D view. So for this, I'm going to use my cylinder base selection tool, and I'm going to grab that cylinder. So the dialog box here is going to have you, it's going to have you select the max thickness that it's searching for. So if I bring this down, let's say it's at 18.5. You'll see I'm not getting that full color range display on my part because I'm not allowing it to search for a large enough distance. So now knowing that this is the thickest part and this is the thickest part and those are around 20 millimeters, we're going to want to bring that up so that you get that full color display all the way around. Similarly with the minimum, you want to make sure that the min is not set too high for it not to be able to calculate the thinnest parts on this O. So once we're happy with that, we can click create and close. So this is going to be the first element that requires a measuring principle. Don't worry about that. We're going to get into that tomorrow, but just for now, I'm going to apply that measuring principle. Opening up the iInspect wheel, which is this little magnifying glass found at the top of the inspection workspace, and then adding the measuring principle reference construction. Okay, looks great. So we can display deviation labels on this as well. A helpful hint, though, would be to open up the iInspect wheel, which I'm accessing by holding Control right mouse button and applying a check, which might be maybe a min and a max. Making sure I have that surface selected under my nominal geometries, sorry. Material thickness here. Oops. And then now applying our check. I'm holding Control. I'm doing minimum and maximum here, and that's displaying me my maximum material thickness and my minimum material thickness. So let's say you're interested in instead of seeing what the actual thickness is, you want to see what the deviation is between the two. No problem. We're going to go back to that check and we're going to choose this material thickness comparison on actual. So this is going to be showing us now the comparison of CAD to mesh instead of just an inspection on what our actual is. So I want to turn off that nominal material thickness check there so we can get the color deviation representation shown like this. Go ahead and click OK. Cool. And now on this one, we can apply the same check, the same min max. And now these are where it's showing the highest deviation or difference between that thickness on the CAD and on the actual. So right here, this is looking like our CAD is about 0.16 millimeters thicker than it is on our actual. That makes sense? Okay, so like I did, starting back with that inspection section, making that CAD exclusive is always a great option when working with your inspections. So using that inspection section on CAD and then defining that clipping plane, they just did theirs in a different direction than I did, which is not a problem. Playing around with that max search distance here. So now you'll see that inspection section is found on the nominal elements and it has this blue icon. So we can drag that out, make that exclusive. Using this view in our coordinate cube, we can line that, square that up. We used our deviation label icon to analyze specific points on our section. Holding that control to get that preview of what that discrete value will be. Under material thickness, we constructed using construct surface and then material thickness, using that 3D selection tool to choose where we want the thickness to be checked and then applying deviation labels the same way that we did on our inspection sections and on our surface comparisons. Great. Okay, moving along now, we're going to kind of get into reporting a little bit. Okay, so we have some great inspections now to work with. So let's just go back to our surface comparison. So I'm going to grab that surface comparison. I'm going to drag and drop it out, show that exclusive. I'm going to square up my view here. Using our deviation labels, I'm going to apply some deviation labels to this surface comparison. Maybe more on the M where I'm noticing some color representation. And now there's a few ways we can report this. So the easiest is to go ahead and just click this Create Report page. So this is going to prompt you into this reporting view. You're going to want to give your report a quick name here. I'm going to call mine Surface Comparison on CAD. You're going to be able to choose if you want this to be portrait or landscape, and then the style in which your report is made. So just sticking with the letter style and then that 3D view. And then once we're happy, we can go ahead and click OK. So now you'll see I have a report page drop down in my Explorer with that view being saved. So let's say I move this part around, I can redrag that view back out and it will show me exactly what it will look like in my report. Let's do the same thing with our inspection section. Let's bring that out exclusive. Again, we're going to line this up. I'm going to use my Relates To tab here to make my deviation labels visible. So I'm going to click the whole header of deviation labels here and click V for visible. You might see some errors here. That's no problem. Once you start reporting, the software is going to let you know what's not included in the workspace. So that's just letting me know that it's not been reported yet. So again, I can click my little report icon here. I can call this my inspection section on CAD and click OK. Great. The last thing we're going to report is our material thickness analysis. So first, I'm going to show that material thickness on the CAD, which is found under my nominal elements. We're going to get this a nice squared up view. And then again, using my Relates To tab, I'm going to go ahead and turn on those material thickness analysis deviation labels. So we'll turn those on there. Maybe we just want to leave the max and min. So I'll delete the other two. Maybe get myself a view that easily shows both of those checks, something like that. And we'll make a report page there and we'll call this our material thickness, min and max. Click OK. Similarly, we might want a report page that just shows our material thickness analysis. Remember, that was our comparison of the CAD to the actual. So we'll drag that out as well. And this gets displayed on the mesh for you. And then again, we can turn on that min and that max. And we can report this as well. And this is our material thickness comparison. So this is like a combination of our surface comparison and the material thickness check to kind of get you that deviation shown between the CAD and the mesh. Okay. So like I mentioned, in your reports, everything's going to be saved within here, all of those 3D views, which you can access now at any time. So sometimes it's helpful as you're inspecting to create these report pages along the way. That's what we're going to do from here on out in the training. So that way that 3D view is saved for you. So using our drop down, our workspace menu over here, mine are pinned. If you don't like them pinned, you can unpin those workspaces and then just rely on dropping down that menu each time, or you can leave them pinned and then choose your workspaces that way. So going into that report workspace, again, I don't want to dive too deeply into this because we're going to cover reporting more on day 3, but you'll see each of my report pages are stored now within that report workspace. Perfect. And also noted now, everything I've made, every inspection I've made in the software, I've now made a report page for, And if I go into my project guide, you'll see I have no errors. Everything is perfectly calculated. Cool. So creating that report page for that inspection section, naming it inspection section like you saw we did. I clicked the little camera icon, which then prompted me into this view, which allowed me to make some minor choices like report style and orientation of report page. We're going to go more in depth into reporting later. I'll dive back into this afterwards, but we can open back up that report page there, and I can edit the deviation labels on our inspection section. So these are going to be kind of your deviation arrangement options. So as we create that report page, they're being placed in the report workspace for us automatically. All of our workspaces are linked together. Another thing I'll dive back in and show you this is how to export those report pages. As you can see in that purple reporting workspace, there's a Adobe logo that's going to be your export as PDF. When you open that up, you're going to have the option to choose where to save it and the project file save name, whether you want it to be all report pages or just the selected ones, and the quality, and whether it launches the PDF viewer after being exported. Cool. So I'm going to go back in really quickly and show you guys that inspection section. Okay. So again, if I click create a report page, and then something that I didn't dive into, which I'll show you right now, is if you click this little pencil icon, that's going to give you a few more options down here, right, such as those labels. So we're going to want to make a selection on the label. You can either choose just one, or if you hold control, you can make a nice box around, and that will select all of them. Playing with the label size, whether you want them to be small, medium, or large. This is going to be aligning them per a line that you draw in the software. This is going to arrange them horizontally. This will snap your labels to an auxiliary line. Here we're going to be able to do on edge of screen, on element, or to the left of element. So for this, we're going to want to do horizontally and then maybe play around with this auxiliary line here, snapping them to the line. Oops, sorry. Okay. My bad with that, sorry. Oh, there we go. Cool. So now that they're all linked together and we have them all horizontal, you can kind of play around with all these different functions. So maybe on edge of screen, on element, or to the left of element. So just kind of play around with these because there's lots of different options here. And then diving into that report workspace, like it mentioned, you're going to have this export as PDF option, in which you can say all report pages, and you can export those. If you select in here, it will prompt you to open up your documents in your folder to choose where they're being exported to. Okay, so let's say you're happy with your project. We're going to want to save our project using our file save as. This is a just pretty basic tool, similar with lots of softwares. So saving that wherever you want that file saved to. Another option here, similarly to how we brought in data, we can export our data. So let's export our mesh. If I go to File, Export Mesh, and then I go to this STL option, which is obviously the preferred. It has this little export icon next to it. You want to make sure that you have your mesh selected, and then choose where you're exporting that to using this arrow here. And then another important is choosing the units there of that mesh export. So my project currently is in millimeters, but if you wanted to export it in, as any of these units, you could easily do so. Cool. So maybe, before you get too far into your project, you're going to want to have it saved using that file, save as, and then choosing where you're saving that project to. This way you can access it later. And then when you're back in that Start Workspace in the software, it can prompt you to be opened as a recently used project. Exporting the mesh like you just saw me do. Using that file, export mesh, exporting it as an STL. That's our preferred export option. And then choosing all of these options on the right here. And when you're happy, clicking OK. Okay, so we kind of cruised through that, which is no problem. We're just going to have time for questions. So, but just briefly to cover what we've went over. Sonia did that company overview for us, as well as an intro into GOM metrology. I covered what is GOM Inspect, our operations, bringing in data, those selections on mesh, basic alignments, which are going to be required, right, to be able to do any further inspections. And then the most basic of our inspections, which are our surface comparison, inspection section, and material thickness. So just also a quick intro into the reporting before we dive too deep into that. And then saving a project and exporting data. Okay, well, thank you everyone so much for joining today.
Yes, thank you, everyone.
And we'll see everyone back tomorrow at 1.
1 o'clock Eastern.
Eastern Standard Time. All right, so as people continue to join, that's no problem. We'll just start off really quickly with introducing myself and David as your presenter and host today. I'm an application engineer out of the Michigan office. David is as well. And just to recap day one, we started with just a quick company overview, as well as GOM's metrology and the technology behind that. And then what is GOM Inspect software? So we started with the general operations within the software. We practiced some data importing with that mesh in the CAD. We practiced our 3D selections on our mesh and on our CAD as well. We briefly went over mesh editing, some basic alignments, our surface comparison, which as you remember is that color plot deviation representation, our inspection section and material thickness. And then we just briefly got into report pages. Again, day 3, we're going to have a more in-depth description of report pages, and then how to save and export from your project. Today, we're going to get into some more complex topics, starting off with our iInspect wheel, moving into measuring principles, just the general workflow of how we inspect in the software, both on nominal and on actual if you don't have CAD in your project. Some of the inspection features we're going to talk about is that outer disc caliper, 2-point distance checks, construction of 2D elements, creating surface points, and then a more in-depth alignment, which is that RPS alignment. Remember, just like yesterday, everything that I'm going to be accessing for the projects is in this folder, which you can download using this link here. Also, you'll notice number 2 has a results complete projects folder. If you open that up, basically that completed project from day 1 is going to be found in there. So we can use that to start out with our inspection on day 2. And then on day 3, we can use that starting with our inspection from day 2. Of course, if you want to restart from bringing in the mesh and the CAD and everything on your own again, that's awesome, just more practice for you, but that is available for you there, as well as the presentations and yesterday's recording. Okay, so let's dive in now into what the iInspect wheel is. This is what we call our intelligent inspection, and you can open it 2 ways. Either clicking that magnifying glass icon that's found at the top of the inspection workspace, which we were in for most of the day yesterday, or if you click Control right mouse button, it will actually pop up wherever your mouse it currently is in the software. So that can be super helpful as well for quicker inspection times. And then depending on what skins, well, it's not skins anymore, now it's packages in the software, but depending on your package, your iInspect wheel might look a little different, but since we're all working with the most basic form of the software today, all we're going to talk about is these measuring principles and checks. That's what we're going to be focusing on. But as you can see, there's also some other modules in there as well. And this gets pretty detailed, so we're going to kind of stay away from that for now. So again, this is that picture of what the iInspect wheel looks like. Starting out with this top quadrant, it looks like a little T, and this is our measuring principle. And briefly, just to kind of cover what is a measuring principle. So it's the way for us to build actual elements in the software. It links your actual to your nominal. So let's say, kind of like going off this photo here, this blue might represent your CAD. It's a perfect edge, but our mesh might look something more like this, where you're noticing this radius to the edge here. So if we build an element on our CAD, that's great. But if we want to inspect it, we also have to build it on our mesh, right? And then check the comparison between the two. That's going to give us our deviation. But playing around with measuring principles is important because which one you choose will get you different results, as you can see here. So don't worry too much. We're going to kind of go through all the main ones you need to be able to do a basic inspection. But just keep in mind that this is how we link our actual to our nominal. You can do inspection in the software without CAD. We're going to do that at the end of today a little bit. But obviously the perks of having CAD is that you have those nominal reference values to compare to. Inspecting without CAD is still going to pull you all of those actual data values, but you may have to manually input the value from a print or something if you're not working with the CAD. And in the free version, it doesn't really matter, but in the professional version, having that CAD is beneficial because that allows you to make project templates. So going over inspection with CAD, is kind of as we saw yesterday, we start with importing. Importing our CAD, importing our mesh. They're floating around in free space, usually, pretty much always, the inspection coordinate system of the CAD gets brought in, so it might have a nice clean view where the mesh is going to kind of be floating around. So you're going to want to align the two together, and this is going to be aligning the mesh to the CAD using, like we did yesterday, either a pre-alignment or a best fit. and that's going to get your parts close enough together so that we can construct on the CAD. And constructing on the CAD is super easy. We're going to be using our construction drop-down menu. And then, as I mentioned, we're going to be practicing our measuring principles. So applying a measuring principle to that to that nominal element is going to create an actual element for you. And once we have our actual and our nominal elements created, we can apply checks. And when we're happy with those results, we'll go ahead and throw them in a report page. Okay, let's get into a live demonstration into the software. So like I mentioned, using that folder from yesterday, you'll see this folder number 2. If I open this up, click too quickly, you'll have all the projects from each day. So I grabbed this day 1 complete project here. So that's what I'm working with right now. My project already has a CAD and a mesh. It already has that local best fit as well as a pre-alignment and all the inspections that we did yesterday. So working on the CAD exclusively, which you can do by dragging and dropping out into the 3D view, by toggling with the visibility, these little eye icons, or by clicking E on your keyboard, that's going to make that element exclusive. So quick recap on those hotkeys. So like I mentioned yesterday, this top menu is static. These options never change depending on what workspace you're in. But if your workspace or your current view of your software looks different than mine, it's probably just because you're in a different workspace than me. So just check between here and make sure you're in that inspection workspace, which is designated by a little magnifying glass icon. So let's construct some elements on our CAD. Using our construction drop-down menu, you'll see there's a large amount of elements we can create. If you have a question about any of these, remember you can click it and you can use this little question mark help, and that's going to give you information about that element. So I'm going to build a couple cylinders just to start off. So going construct down to cylinder. And since we're working on our CAD, you'll notice most of these construction options start out with this auto, and in parentheses, it will say nominal, which is what we call our CAD. So when you're working on the CAD, that's going to be your best friend. So if that's an option and you're working on the CAD, 9 times out of 10, you're going to want to choose that. So we're going to click auto cylinder nominal. Paying attention to this box at the bottom that tells you what mouse keys are required to make that selection. It says use control left mouse click. So I'm going to control left mouse click on a cylinder shape on the CAD. It will automatically name it cylinder 1 for me, but you can go ahead and name this anything you want here. And then when you're happy with that creation, you'll see I have a box here, as well as the create and close, and these little symbols match up. So just the check will create that function or that element, but leave open that dialog box so you can go ahead and continue to construct elements of the similar type. So with that construction box still open, I can click another cylinder very easily. And once I'm happy, I have enough cylinders in my project, using that door either here or going back to the dialog menu and clicking it here. They both do the exact same thing. That will close out that menu. So we have 2 cylinders now constructed in our project, and you'll see there's a little error symbol next to them, and that's letting us know that we haven't applied a measuring principle. There's a few places we could see this. If we click tab and open up the properties, or come to the right where you'll see this little 2 arrows to open this properties box, that is going to tell you the measuring principle is missing right here, Or if we use our project guide, which we used a little bit yesterday, it will tell you the same thing, measuring principle is missing. So to open up our iInspect wheel to apply those measuring principles, we can use the magnifying glass right here. That's going to open up that wheel, and by clicking the header, I can kind of drag it around. I can also control right mouse click, and that will pop it up wherever my mouse is on the screen. So that can be really helpful. So clicking measuring principles, this list, similarly to our alignments, changes depending on what the software thinks you want in your project. So it will only give you options that relate to the element you're trying to build. So for a generic geometric element, this is going to be our planes, cylinders, lines, cones, anything that's a basic geometry. We're most of the time going to use this fitting element. So if I click this fitting element here, you'll see I have some options on how I want this actual element that correlates to my nominal to be built. So you're going to be able to choose the method in which it's constructed. Gaussian is always going to be default, which you can see is just an averaging of all of the points that make up that geometry. Switching to something like Chebyshev, you see it doesn't get rid of any of the outliers. Something like our Max Inscribed is going to use those minimum points, and then minimum circumscribed will use the maximum points. So these two are going to be more options for a go or no go kind of check, but for an actual dimensional check, we're going to want to use our Gaussian best fit. The points used is automatically going to be 3 sigma, but these is just, how many points and what points is it using for that data selection? How many of the outliers is it considering based on that statistical bell curve I'm sure most of us are familiar with. As far as the selection parameters, I personally would say just for this training, I wouldn't dive too deeply into those unless you have a very specific need for it. And once we're happy, we can go ahead and click OK. You'll see now I no longer have an error next to that cylinder. And just to kind of show you what the software was doing behind the scenes by applying that measuring principle, if I open up actual elements in my left Explorer menu, and then under geometries, fitting elements, and under cylinders, you'll see this cylinder now exists and is actually linked to my nominal. It was named the same for me automatically. So that's why measuring principles are nice. It's a really quick way to be able to build to keep from having to make multiple constructions. So let's do the same thing to cylinder number 2. Remember, if my iInspect wheel maybe went away for some reason, we can get it back by clicking Control right mouse button. And using that fitting element measuring principle here, I'm going to use the same principles I did last time and go ahead and just click OK. Awesome. So now that we have 2 cylinders in our project, we can do a diameter check. So grabbing the header of cylinder 1, you can see it's grayed out. That means I've selected it. And then going to this check in the iInspect wheel, you'll see I have a few options here. I'm going to go ahead and click diameter. You can make multiple selections by holding Control down while you click, but I'm going to just click diameter for now. Again, this is going to receive that name automatically based on whatever you named the nominal element. And we're going to allow it to be checked against nominal. So this 60 millimeters is pulled from that CAD. And we're going to be able to assign a tolerance here as well. Something like plus or minus 0.1 is fine. Remember, This is also kind of found in our legend when we link that upper and lower legend limits. But clicking this bracket will allow you to make your lower limit different than your upper limit. For this example, I'm just going to leave them a plus or minus 0.1. And then you'll see I have a preview over here as well. That's giving me kind of what that actual is coming out to be and the deviation and a check, which is shown by this color box. So if I switch this just kind of based on the results I'm seeing to a plus or minus 0.2 tolerance, you'll see now that diameter check is passing. So we can click OK. And we can do the same thing for this cylinder, going back into that check and then clicking diameter. Again, you'll see against nominal. So these cylinders are the same size on our CAD, leaving that tolerance source manual and then sticking with that plus or minus 0.2. This is just a guess. If I had a print in front of me, I might know what this tolerance was supposed to be. And we'll click OK. Cool. So let's kind of talk about how we can get this to be displayed for a report page. I'm going to close out my iInspect wheel because I'm done with that for now. I'm going to get a nice view of these cylinders. So I might square up and I might zoom out a little. Now, this is kind of difficult to see exactly what it's checking, specifically even if I click off of that cylinder. This is not really showing me what diameter I'm checking. If I click the diameter symbol in my label for cylinder 1, you'll see this little blue box will show up. And I can actually click this and I can drag it up and off of my part. This is going to give it a separate label from that element label. So if you want to hide the element one, just click the header and go ahead and click I on your keyboard to make that invisible. We'll do the same thing over here, clicking the diameter symbol, dragging those leader lines off of the part, and then making that actual element invisible. We don't need it for the report. And once I'm happy with how that looks, I can click my Create Report page to save this view for me, as we saw yesterday. And I might name this Diameter Checks. Looks great. Go ahead and click OK. Now, if I move this around, it doesn't matter because I have that view saved for me. Okay, let's talk about another dimensional check we can do super easy in the software, and that is a outer disk caliper check. So let's say our print is requiring us to know what the width of this part is. I might want to construct, go down to distance. You'll see we have a lot of distance checks or distance constructions we can build. We're going to use this outer disk caliper. So the outer disk caliper works very similarly to a typical caliper you might use physically. You're basically going to want to tell the software which 2 points it is checking the distance between. So clicking 2 points on either side of our CAD, starting with up here, and it's telling me Control mouse click. That's our first point. The arrow has now automatically moved down to the second drop menu, where I will select that second point. And now it's telling me I have to tell it in which direction I want to check. Or I can allow it to compute the direction automatically. For this instance, I might tell it I would like to check it in the Y direction. And now you'll notice my dialog has changed, and now it's telling me make my selection of points. So most of the time, you're going to have to make a point selection in the software. Just to keep it super simple, I'm just going to click this select all in the bottom, and that's just going to grab all of that data for me. And you'll see it gives me a preview distance of 300 millimeters right here. Before we click create or create and close, we want to make sure to edit the clearance and the radius. So that's these discs, which is why it has the name outer disc caliper, telling it how far away we want to start from the part. So obviously we don't want to start directly on the part. We want the calipers to close onto the edge of our part. So we're going to make sure to give it a little bit of room for it to be able to close. And then this radius is totally up to you. We can make it as big as we want to encompass the entire length of the part. And this just means whatever point it hits first, it will use that point. So this is going to kind of get you probably the maximum distance. Or we can make it very small and just check at that specific spot that I created those surface points. So it doesn't matter. You're just going to want to use whatever is relevant for your print. And I was able to, if you saw, I was able to kind of scroll through those numbers really quickly. I just clicked on this box, and if I hold shift, I get kind of coarse adjustments. If I hold control, I get my fine decimal place adjustments. And if I scroll, I just get regular. It just goes down by 1 millimeter each time. And then once we're happy with that construction, we can go ahead and hit create and close. Cool. So this distance check is receiving an error, which is because, you guessed it, we have not applied a measuring principle. So it's going to take some practice in the software to remember that you need measuring principles. But I promise once you play around for long enough, it's just going to be first nature. So grabbing my iInspect wheel, I'm going to click the little T, and I really only have one option here, but this is the correct option, and that is reference construction. So you kind of have to think of it as if you're in the software, you're referencing all the parameters we told it prior for point selection. So this is not being fitted to our actual part at all. It's just referencing the construction of that outer disc caliper. Hopefully that makes sense. And then from there, we're going to want to check this. So I'm going to check it, of course, in the Y direction, paying attention to my coordinate cube at the bottom here. Again, against nominal, it gives me this previewed 300 millimeters, and we can manually type in our tolerance. So something that I also want to cover, since this is the free version, if I click OK, and then I try and reopen the parameters on this by either right-clicking, by clicking F4 on the keyboard. And if I want to make changes, you'll see the only way I can make changes on this is if I have the professional version. And that's just because this free version of the software isn't parametric, unfortunately. It's still a really powerful version of the software. We just can't make changes. So you're going to want to make sure that you're happy with everything in your creations before you click OK. You can also really easily click this and click delete. Delete it out and just make a new one. That's an option. Or if we click tab on this element and then go down to, click the dimensional check and then go down to tolerances, we can edit it in here as well. That's our properties tab of that dimensional check. So to be able to change that view, we're going to want to make sure our part's squared up. Select that LY dimensional check. grab that little blue box and drag and drop it off of the part. I can make that distance invisible. And now I have a very clear representation of what I'm checking. There's definitely no confusion here as to what this distance check is. And when I'm happy with that, I'll maybe make these invisible. And maybe just for practice, we'll do another distance check on the length of the part. So we'll go back into construct. Go down to distance, outer disc caliper. It's going to open up that dialog box for me. We're going to pick a couple parts, a couple points. Maybe this time I'll click in the center of that edge or that plane. Again, control left mouse click on the right side. We have our 2 preview points, telling it which direction we want to check, which is going to be the X this time, which makes it super easy because this is a square part. X direction, and then again, we can click select all. If you want another option, we could use maybe like a plane-based selection and select just those 2 outer edges. Really, it's kind of up to you and whatever you're trying to achieve here. And then once you're happy with that, maybe this time I'll make the radius span the entire length of the part. And we'll click create and close. So again, this is going to get measuring principle. I'm holding control right mouse button there. Reference construction. And then maybe a distance check. Again, you could check distance in X, Y, Z, but for this case, we're going to do just distance in the X. And once we're happy with all of this, we can click OK. Remember, to be able to control those leader lines, having to select that actual dimensional check that's currently attached to that distance label. I'll drag that up and off the part. And I will make that distance check invisible. There we go. Now we've checked the distance in the X and Y direction, and we can make a report page of this, clicking our report page icon. And we'll call this our length and width check maybe. Saying okay. Looks great. So those are just some basic 3-dimensional element constructions. You're not restricted to just cylinders. There's some cones in this part. We can check maybe that as well. We can do a construct cone. Again, you're going to see this auto cone nominal. Control left mouse click on there. Create and close. And now applying the measuring principle. Again, this is a fitting element because this is a basic 3-dimensional geometry. The default parameters, which most likely will work, which is going to be our Gaussian and our 3 sigma. That's kind of what GOM recommends. That's what's default when you create this element. So saying okay. Now, if I go under actual elements, I now have a cones dropdown where you can find that actual cone 1, which the software built for me. And I can check this cone. And obviously the checks for the cones are going to be slightly different because it doesn't really have a set diameter, but that is just another construction we can do in the software, just to kind of show you guys. You can play around with multiple of these after we're done with this training as well.
Maddie?
Yes.
Could you, excuse me, could you go over the report just one more time briefly? Like
Yes.
how you took the image and did the title and rotated it and all?
Yes.
Thank you.
Okay, cool. So let's recreate that report page of these two distance checks, right? So just choosing my view before I get started, squaring up in the Z direction here. I'm playing around with my labels, making sure I'm happy with how everything looks. Now to report this, I'm going to want to click the report camera icon up here, create report page. It's also Control P if you like using hotkeys. So this is going to bring you into your basic reporting page where we can call this whatever we want. Where we can choose the style in which we're reporting. So just the 3D view is perfectly good for what we're doing here. Another option, maybe you want the 3D view plus a table. That's kind of a popular one amongst customers. And then playing around with if it's being in portrait or landscape. And then we kind of played around with this a little bit yesterday. Again, we're going to kind of get into reporting on day 3. So don't focus too much, but we can click this little pencil where we can play around with this view. I can drag everything within here. Maybe I'll want this squared up nicely. I'm holding down my middle mouse wheel to be able to pan like that. Because if I were to just hold left mouse button and drag, that would actually change my view. But we can still use the coordinate system that's found down here to square it up. And then once you're happy, maybe playing around with the size of the label, maybe you want them larger. Really, there's a lot of things you can do here. And when you're happy, you can click OK.
Real quick, Maddie, the leader lines, how you select the actual check to move the leader lines,
Yes.
how you want them.
Perfect. Yep. So that can be a little bit confusing. You have to, let me kind of go back into.
You can just move that one.
Yeah, so this label is already separate from the distance check. But yeah, basically, if you aren't able to just click this header to get this box to show up, that's because you have to actually select the LX beneath it. Once you click the LX, if your header isn't, or your label doesn't look like mine, that's going to get you that little square to be able to drag. Hopefully that makes sense. If not, I can make a new construction to show you guys that.
He said perfect, thank you.
Okay, awesome, great. Yeah, so once you kind of drag those leader lines off the part, it makes the distance check its own label. So that can be a little bit confusing, but that's just kind of how the software operates. So hopefully that makes sense. All right. So just to kind of recap all of those examples, we started by using that construction drop-down menu to actually build our geometries. So sticking with those auto options, like auto cylinder, auto cone, like we saw, those are preferred for when we're building on our CAD. Making our CAD exclusive using that hotkey E is definitely going to be your friend when trying to build on the CAD. And once you're happy with where that element is being built, you just click Create. If you want to just continue to build cylinders, they're just going to keep getting renamed automatically for you. Or go ahead and click Create and Close, and that will close off that dialog box. So as you notice, this little red circle with that white rectangle through it means something is wrong. The software is telling you you have an error in your project. So there's a few places we checked on this, both in the Properties tab, which we accessed by clicking Tab, or in that project status at the top of our Explorer. It would let you know, hey, you have a measuring principle missing. a very common, I would say almost the most common mistake I see in a project, just because it's a little bit confusing at first, but the more you practice with measuring principles, you won't even think about it. You'll just be applying them. No problem. So to apply that measuring principle, we opened up our iInspect wheel, which we accessed both in this magnifying glass shown here, as well as using control right mouse button to automatically get it to come to wherever your mouse is in the view. And then once we had that wheel open, we clicked our fitting element, which another thing that we can note, all of our elements we've been building on the CAD have this little blue icon. That's because blue is nominal. And then the fitting element measuring principle, you might notice, is designated by a green icon, letting you know this is to build your actual element. Your measuring principle dialog box will look something like this. Mine, I had extended, I had some more expert parameters, but the main ones we're focusing on is choosing that method of fit, because of course, our CAD is a perfect cylinder and no part is ever made perfect. This red is exaggerated, but it is meant to show you what the surface of your actual cylinder looks like. And the green is the representation of what that actual element is going to look like once it's created. So it's going to just be using this averaging of these points to create the cylinder for you. And the only way we control this is by the method of fit and the point selection used. So these are going to be very important when playing around with creating actual elements. And once we click OK, you'll see cylinder 1 no longer shows an error. And now in our actual elements tree in the Explorer, a cylinder 1 lives in there. And it is 100% linked to that nominal cylinder for you. So once we have an actual and a nominal cylinder, we can check. We can check the difference between the two. Doing a diameter check can quickly show us how different those two cylinders are from each other. Right here, I'm getting about a 0.15 millimeter deviation. Just to let you know that your actual cylinder is just slightly smaller than your nominal cylinder. Playing around with those leader lines, this shows it really, really well. When you first construct that dimensional distance check, or it was a diameter check, sorry, it's all going to be in one label. But when you click the line of that label that has that diameter icon, a little blue box is going to show up, and you're going to be able to drag that up and off of your CAD as shown here. That's going to make your two labels now independent of each other, and then it just suggests, just like I did, to click I on that cylinder 1, just make it invisible. You don't need it in your reporting because the name was linked for you. So kind of like I did, creating a report page to show those cylinder checks. As we go through an inspection layout, sometimes we might want to make report pages along the way before we get too far into an inspection, save those views for us so that we can reference them later and we won't have to play around with hiding and unhiding. It's easiest if you just do it all as you go. Another check we covered is that disc caliper check. So playing in that same construct drop-down menu and then going all the way down to distance. Here, we didn't use that nominal distance like we did for our three-dimensional elements. Instead, we use this outer disc caliper because this is basically the easiest way to be able to check a 2-point distance with the minimal amount of constructions needed prior. playing around in this menu, like I said, you don't have to have anything built prior to being able to do this. All you have to have is the CAD. Choosing those 2 points, adjusting the clearance and the radius, and then choosing that direction myself. But we can also allow it to compute the direction automatically. Doesn't really matter, especially if we're going to be applying a check in a specific direction. So just kind of keep that in mind. Another common mistake I see all the time with this distance out or with this outer disk caliper construction is forgetting to make a selection on our 3D view. So remember, I just selected the whole part. That's why kind of why you see it like grayed out and red here. You have to tell those disk calipers basically what to run into. You have to tell it when it should stop, the data it's going to hit. And once you're happy with all of that, you click create and close. Just kind of another view of that. So they went ahead and made those disks the width of the entire wall there. Definitely a great option if you want that maximum distance check. That will get you that. And as it mentions here, that clearance is needed just in case the mesh is a little bit larger than the CAD, right? Because we have to allow it to be able to run in 2 data points. We don't want to start already closed on 2 data points. And that used the measuring principle reference construction, which is different than fitting elements. We aren't physically fitting to the surface of this part. We're just referencing the construction of those calipers in that caliper dialog box, referencing that construction in the sense that the data selection is 100% based on that, not based on any sort of fitting algorithm. And then depending on the distance that you're checking, we applied a distance check in the X direction as shown here. Doing the same thing in the Y and then creating that report page. Okay, does anybody have any questions on that portion?
If you could go back to and just show how you hide and unhide or invisible, make visible.
Yes,
element real
absolutely.
quick.
Yep. So kind of like you saw here, this distance check I have. Another helpful element of the software is this sub explorer down here. With whatever I have selected, I'm going to have all the elements kind of related to it, especially if I go to, there we go, relates to, and I turn on that distance, right? So after you pull that leader line out, it's going to make its own independent label, and that distance check is just going to be chilling on your part here. We don't want it. Go ahead and click the label, and then click I on your keyboard to make that element invisible. So I for invisible, E for exclusive, and V for visible. Those are your 3 kind of letter hotkeys that I encourage you to practice. And if everyone is feeling comfortable up until this point, we can go ahead and take a 10-minute break. Coming back at, we'll just come back at 2. We'll come back at 2 and continue on. Okay, let's hop back into it. Great job so far, everybody. We're about halfway done with today's training session. Really good questions. So moving along. We're going to jump back into the software now. I'm going to cover just some more slightly advanced inspections. And I only say slightly more advanced because they're going to require other elements to be built prior to be able to constructing them, right? So it's like kind of more of like a 2-part process. Again, grabbing our CAD, I'm going to drag and drop that out, show element exclusively. Once we have just our CAD exclusive, I'm going to first go into what we're going to be constructing, kind of show you what it looks like. Sometimes I like to work backwards from constructions to kind of see what's required. So if I click this distance, let's say we're going to be checking from the center point of this cylinder to the center point of this cylinder here. We want to do, or honestly, we could do from upper cylinder to the center of this cone, maybe. That's going to be a 2-point distance check. And as you see, to be able to use this construction, I need to have 2 points made prior. So we don't want to worry about this quite yet, but it is good to know we're going to need those 2 points. So you might be saying, why can't I just use both of the cylinders that I built earlier? And that's because your cylinder is a 3-dimensional element. So kind of trying to measure a point to point is a little tricky, right? You're kind of get some variation of results. You're going to want to stick with 2D elements for this kind of 2-point construction. So to do that, we're going to kind of play around with building points. So starting with some basic element constructions, we'll do a cylinder right here, create and close. And then we'll build a cone on the other one here, and then create and close on that one too. So we're getting that error like we saw last time, and that's just letting us know that we need our measuring principle. So opening up our eye inspect wheel. Both of these are 3-dimensional geometries, so they're going to be getting fitting element. And click fitting element there. Again, not really paying attention to our data selection parameters. It's just a little bit more advanced, and just sticking with the number of points used and the fit method, and saying okay. And then doing the same thing with our cone, applying that measuring principle fitting element. Awesome. So now we have 2 geometric elements. And again, we don't want to use these for our 2-point distance because they have a center line and not really an exact point center. So next step is going to be to construct some planes. So using our auto plane, which is again in parentheses nominal, meant to be used on CAD alone. I'm going to select that top surface. I have a lot of good data up here to work with. So I'm going to select this as my plane 1. This time we're going to use this little box that pops up. This is really helpful to be able to construct quickly. So if I click this check, you'll see it close that out for me. I can move my mouse right over to the second surface I want to build a plane, Control F mouse click, and this time I'm going to click the door icon, which is our create and close out of that construction dialog box. Both of these planes are now currently highlighted. Since they're the same element, technically since all 3 of these, or all 4, are fitting elements, you can apply them all at once, whatever you have selected. So here, for example, I have both plane 1 and plane 2. If you guys don't, say you clicked off of it, just click that header, that plane 1 label, hold control, grab that plane 2. We have both selected. I can go into my measuring principle and apply a fitting element to both of them at the exact same time. So this is another inspection tip. And then go ahead and click OK on that. So now we have 2 planes and 2 elements that have this center line that runs up into this plane. So this is perfect parameters to be able to build an intersection point. So if I construct point and then go down to intersection point, I'll give a little pause right here. So grabbing that intersection point, it's going to ask me to choose a line. So your line is your center line of your element. So the cylinder has that center line running through it. So that is a good option. I can either control click it on the label, or I can use the drop down and kind of scroll through and see what my options are here. So that's cylinder 3 intersects plane 1. You're going to get a preview point shown here. And when you're happy with that point selection, it automatically named it point 1 for me. We'll just click create. So we're going to use the same construction menu over here. Our line this time is our cone intersecting our plane. And again, you'll see you have a nice point displayed here as well. Create and close. All right, so what do you guys think the measuring principle is going to be for these 2 points? So so far, we've played around with fitting element and reference construction. Wrong box, sorry. So you'll see you have both options this time. So it's going to be a little bit confusing. You're going to have to use your judgment here to select and make the right choice. But this is actually just a reference construction. It's not being fit to the surface of anything. We're not really even using the mesh data. We're just referencing all the prior constructions to build this point, which is floating, kind of in this free space, but it is locked in the directions to the fitting elements we constructed. So we'll do the same thing to point number 2, apply the measuring principle, reference construction. And now we have 2 isolated points, and we can construct that distance that I mentioned, which is construct distance, 2-point distance. Awesome. We can grab point 1 and point 2. I'm holding control while I'm clicking those. You're going to get that preview distance like we saw on the outer disk caliper check. And that's going to automatically be named for you depending on the names of those 2 elements. So that's really helpful. And that's why it's important to kind of keep your elements named how you want them according to your print or whatever makes the most sense to you for your project. Create and close. This check. We built the check. It's not over yet. This check now, you guessed it, needs a measuring principle. The software makes it easy for you this time. Your only option really is reference construction, but hopefully it's kind of setting in now why it's referencing just the construction. It's not fitting to any collection of points. And once we're happy with that measuring principle and we have our 2-point check, we can check this. And this is going to be in the X direction. Against nominal, you might notice you can technically drop this down and you can type in a fixed value if you maybe have one that's different from what the CAD's pulling. But generally, if you're working with the CAD, you're going to want to keep this at against nominal, the nominal that it's pulling. And remember to apply your tolerances here. If you don't see that, it might be hidden. So you might just quickly click OK and skip over it. But remember, this tolerance box is found by this little drop-down menu. It's going to have your tolerances in here. Go ahead and click OK. So now we might want to line that up again. We're going to use our trick to be able to pull this up and off of the part. So again, if I click that LX, I get that little blue box, which I can drag up and off of my part. And I can hide all my other elements by clicking I on them. We don't really care about any of these for our reporting. That was just what was required to be able to get this construction. And then once we're happy, we can create a report page here. And we'll call this a 2-point distance check. Looks great. Cool. So as you saw me do here, and there's just slightly different. There's a lot of different ways in the software to kind of achieve the same outcome. but they use this lower cylinder and then the upper plane, applying fitting element to both of those. Then constructed their intersection point, just like we did. Again, we just use a slightly different cylinder. That does not matter because the center line of the cylinder technically runs infinitely, right? That's just kind of how cylinders work. And then we applied the measuring principle reference construction to that intersection point. So this looks identical to how we created ours, which was by first constructing that cone and then constructing that plane. You can see they did theirs. They built the cone, then the plane, then did a fitting element to both. Again, just a little bit out of order than how we did it, but same outcome. And then constructing the intersection point there. Oops, sorry. Constructing that intersection point with the cone as the line intersecting onto the plane. And that got the measuring principle reference construction as well. Cool. So now that we have everything built, we could go into construct distance and grab that 2-point distance construction and then use those intersection points we built as our 2 points. Which this is going to be it's very repeatable method because that point is locked in all directions. We don't give any room for variance here. And then that distance check, remember, also needed the measuring principle reference construction. Great. Looks awesome. Okay, cool. Now we're going to kind of get into some two-dimensional analysis. So I'm going to grab my CAD, drag and drop this out onto our 3D view to make it exclusive. So when we're talking about two-dimensional inspections, this would be something like our angle inspections or our circles. So first, we're going to start out with constructing an angle. So let's say we want to check this angle right here. There's a few different ways we can do this. Something that might initially come to mind is to build planes on those surfaces. We can absolutely do that. I can show you that really quickly. So going construct plane, auto plane, grabbing that bottom surface there, and then this surface over here, can close, assigning those the measuring principle fitting element. So you can see the dialog box for the fitting element is a little bit different. It's just kind of giving you a diagram of the red being all the different points along those surface, obviously exaggerated, and then the green is kind of that fitting that you're seeing. So if I switch to Chevy Chev this time, you'll see it's including more of those outlier points. This is just an overall average where the Gaussian is kind of like a formulation that excludes those super outlier points. Once we have our two planes, we can go down all the way to angle, and then pick that 2-direction angle. So we're checking between basically the X and Y direction here. And if we grab that plane 3, plane 4, you'll get this kind of preview angle. Create and close. And this angle is going to receive measuring principle reference construction. Again, the software is kind of dynamic in the sense that it tries to give you suggestions for what it thinks you might need. And now that we have this angle, we can check it in the X, Y direction. I'm pulling that based off my coordinate cube down here. So that's a 3D angle, right? We're kind of pulling off of both of these planar surfaces, which is fine, but it's just not as specific as it could be. So let's go ahead and make that invisible for the time being. We'll make the angle invisible too. Now let's talk about how we could create that 2D angle inspection. And we're going to do this first by cutting a section. So in the software, if you're trying to accomplish a 2D inspection, you're going to need section cuts to be able to do that. So I'm going to go into construct section, and we're just going to be building single sections, nothing crazy. So I have my reference plane currently set to plane Z, but you might also notice if I drop this down, I can also use any of the other planes I built. So like plane 1, that was off of that upper surface there. I can totally use that as my reference plane if I want. If you don't have any planes in your software though, you might want to use the plane Z. Both are going to kind of get you that same outcome. And then I'm going to play around with this position. So bringing this, you can see up through the part until it cuts through that area of the M that I'm interested in inspecting. So it's not allowing me to apply the measuring principle, or I'm sorry, it's not allowing me to create this yet. It's telling me, please select points in the 3D view. So I could say select all, and that would create a section cut across everything this plane is cutting through. And that's totally fine. But instead, I'm going to use my select through surface right here. And I'm going to click 4 times around the M. Click, click, click. And then hold right mouse button to make that selection. And just grab the M because that's really all I'm interested in for this inspection. And it's good practice to play around with our selection tools. So once I'm happy with the section cut, I can create and close it. And once again, apply measuring principle. And this is once again going to be reference construction. Trying to not confuse you guys, but it's reference construction because it's just referencing that plane, which I used reference plane, but let's say you use that fitting plane, right? It's just cutting a section through there, referencing that plane we used. Awesome. So I can grab that section there, and I can click E, and I can show that element just exclusively. I find this to be easy sometimes because we're working with 2D inspections, so might as well just work on that section cut alone. Again, we're trying to inspect this angle. So I don't want to go ahead and just say construct angle quite yet because we need to have some sort of elements built prior. I'm going to use lines. So going construct line and then still auto line. We're still working on only nominal elements at the moment. And holding that control left mouse button to get a line on that edge or on that section cut of my M. Something you can play around with here is the orientation of that line. There's only 2 options. For this, we're going to want the line to be facing in this direction since we're checking the angle in this direction. Create that. Another one right here. That one automatically placed that line arrow in the direction I wanted. So we can click create and close. So now we have 2 lines and they need a measuring principle. And it's going to be fitting element because this line is being fitted to that data. So it's going to have, ups and downs, bumps and all that in our section cut. And we want to use that surface to create our fitted lines. clicking OK. Awesome. So now we have 2 lines and we can construct our angle. So going construct, angle, to direction angle. Direction 1 is line 1, direction 2, line 2. Pay attention to this preview, right? So as I switch the directions of these lines around, you'll see it's previewing what angle I'm checking. We want to make sure that the angle we're checking matches our print, which this is obviously a generic example, but this is the angle I'm after. And then we can click create and close. Once again, this needs a measuring principle of reference construction. We're just referencing the location of those 2 lines. Great, and now we can check this in the X, Y angle direction, just like the last check we did. And click OK, cool. And now we have 2 angle inspections. So if I go down, dimensions, angles, I can turn on both of our angle dimensions. Angle 2, which was done based off of those lines. It's our 2-dimensional angle. And angle 1, which was based off of all of that planar data. So you can see you are getting a little bit of variation. If I increase the number of decimal places. Maybe I can't. In the free version after the fact. Oh wait, sorry, that was under length. No, I'm just being silly. I want us to change it under angle here. Apply, there we go. Perfect, sorry about that, everyone. So there we go, yep, so now you can see as I've made it broader, both the nominal and the actual for each is kind of giving me a different result. Okay, now let's kind of talk about a way that we can inspect circles. So I suppose while we're here, we'll make a report page. I'll turn off my lines, something like that. And we can throw this in a report page and call this our angle. Inspections. Cool. Now let's grab our CAD back out. We always want to start with our CAD when we're doing a new inspection. And we're going to try and inspect a circle. So let's just say this circle right here, we want to inspect it. So your instinct might tell you to go to construct circle, auto circle. I'm going to show you why this is not a good idea. If I create and close on that, and then try to apply the measuring principle fitting element, which is what we're used to, it doesn't know where to place it. And that's because patches on CADs have perfectly clean lines in which we can construct these circles. But realistically, our mesh probably has more of a radius curve to that circle area. So this is not going to be a good option. Fitting element isn't going to be a good option. There's 2 ways we can do this. I'm going to start with the difficult way, and then I'll show you guys the easy way. So the more difficult way is just constructing a section through that circular area so that we have a 2D section, and then building our fitting element on top of it. So let's start with that. So we'll go to construct, section, single section. I'm going to drop this down into that area that you see down here, maybe just 10 millimeters. So we have a section cut through, and maybe your print tells you exactly how far into this section it's supposed to be, which it very well might. And then again, I'm going to use my select through surface to just kind of grab. This time I'm holding that left mouse button to draw a circle, an organic circle, and then selecting that. And then you'll see that 2D section preview. So So we'll click create and close. Looks good. And that's going to get the measuring principle reference construction. Yep. Awesome. So now working off of that section cut, I can construct a circle, auto circle onto that cut. As long as you click close enough to it, just make sure that that it's being previewed on that section cut before you click create and close. And then that's going to get the measuring principle fitting element because it's just being fitted to that cut section of the data. No issues here. The actual circle knows exactly where to be built in the software, and we can check this for diameter. Great. So that's fine, just a few extra steps, but now I'm going to show you guys the easier way. So I'm going to hide that, hide my section, just by clicking I, and I'm going to construct a circle, auto circle, at that upper surface again. And I know you're going to say, Maddie, you just told us not to do this, but I'm going to show you how to make this work. So with this circle created on this upper edge, we'll click create and close. Now we're going to open up our measuring principles, and you'll see it's the very first suggested option for me, and that's called projected offset section. Few dialogues to pay attention to in here. Number one, distance to element. So what we're kind of doing is using these three parameters to, first of all, build a plane, and then second of all, project that plane down into the part, just like we kind of did when we were doing our section cut. So playing with distance to element. We want to make sure we're backed off the element a little bit. We don't want to be directly on the edge there, just because we have to keep in mind of this radius that is on our actual. And then how far we want to project down into the part. So obviously we don't want to be up above that circle. We want to project down into the circle. Looks good. And then the final thing we want to play around with is the width. And this width is how much data is being used to build that plane. So you want to make sure to have a good chunk, but you don't need too much. And then once you're happy, you click OK. And that circle is built for you. We can check it the same as last time. We can check the diameter. Awesome. So let's pull back up that other circle. Here. Just to kind of see how they differ. Now these are probably cut at different sections, so this isn't necessarily comparing apples to apples, but as you can see, both are really good options for building that two-dimensional circle. And these circles are good options to use as points in distance checks because they have fixed center points. Awesome. So looking back on that 2D geometry angle I built using that single section cut through the M, we used reference construction there. And then we built some lines. We built auto lines, nominal ones, which are shown by this blue logo, so that we could check that in two directions. And both of those received the measuring principle fitting element. And we went on to construct our 2D angle, which we had to choose the two directions of, being line 1 and line 2. And as you can see, we played around with the orientation of the lines to make sure we were getting the preview of that angle to be where we wanted it to be. And that angle construction received the measuring principle reference construction. And we checked it in the XY direction. Cool. Now let's talk about those 2D circles we built. Starting out with trying to construct that auto circle just through that M, through the O on the GOM block, which is different than what we used, and then trying to use that measuring principle. Okay. Moving on. We're going to talk about some more in-depth alignments. Yes, just making sure. And I think we're right on schedule too. Okay. Open back up our project. Grabbing our CAD, dragging it out exclusively, so that's all we're working with. And working in our pre-alignment, we're going to do a common alignment in the software and amongst many businesses, which is an RPS alignment. So an RPS alignment is kind of like your plane line point, which locks your part in all degrees of freedom. So to do this, we're going to use surface points. So using a minimum of 6 surface points, we're going to place them in the Z direction, the Y direction, and the X direction. So going over to construct, point, and then surface point. I'm going to start by creating 3 points on this planar surface of our part. So picking 3 points far enough away from each other so we get good coverage on this plane, holding control and then clicking left mouse button. Before I create, I want to go over and make sure to give this a designated name so I don't mix up my surface points. And since this point is in the Z direction, we're going to call it Z1. Next point, control clicking on, again, this Z planar surface. The software is now automatically naming it Z2 for me. Clicking create. And then again, creating a 3rd point, calling it Z3, creating that. Cool. We have 3 points now locking in our Z direction. Now I'm going to turn the part to the side. Now we're looking in the X direction according to our coordinate system. And I'm going to select 2 points in the Y direction. So holding control, left mouse click. We want to name this accordingly so we don't mix up our points. Call this Y1. And then again, on this Y plane, we're going to call another one, and that's going to be Y2. So we've now locked, hypothetically, 2 points in our Y direction. And then that final point that we're missing to lock transition in the X direction is that X point. So we're going to click somewhere on this right side of the part. We're going to call this X1, and then create and close. Okay, so let's talk about measuring principles of surface points. This is one of those elements that has a variation of options you can choose. You can see if I open up my measuring principle list, there's a lot more than kind of what we've seen so far. The 2 that we're going to focus on is project onto actual and intersection with mesh. So intersection with mesh is going to use that normal vector on the surface of the CAD and just drop it down directly onto your mesh. It doesn't really give you many options here. You're just assigning it and then clicking OK. The other option would be project onto actual, and this is more going to be the software searching for the shortest distance, and it does this by using the normal vector on the mesh to project up onto that point in whatever is the shortest. And honestly, sometimes these give you the exact same result. Sometimes they don't. For today's example, just because it's a planar surface, we're going to use intersection with mesh. I'm totally okay with it. Just projecting this point, which is just an arbitrary point that I placed on the surface of the CAD. And then clicking OK. And now that we have those 6 surface points built, we can open up our alignment drop-down menu here and go into RPS alignment. So in your RPS alignment, it's going to name itself RPS, and you're going to have to tell the software what points you want to use for your RPS rules. Mine are all currently selected because they are all this shadowed kind of gray. If yours aren't and you accidentally clicked off of them, remember you can hold control and reselect all of those very easily. And once they're all selected, we can add them. If you hover over here, it says add selected elements. Cool, so the software is going to use that vector to automatically fill out a direction for you. Again, since this is like a cubic part, this is very simple, but if your part was more organic, you just have to kind of play around with these directions. And if you see, I can drop down. You don't have to pick to just one direction. You do have options like XY, XZ, or YZ. But for this example, we're working with X, 2 Ys, and 3 Zs. And then you'll see previewed here our deviation. So your RPS alignment is going to try and get these 6 points to the smallest deviation it possibly can. And then click OK. Cool. So now let's just see kind of how that changed our inspections. So if I were to open up inspection, surface comparison, and drag and drop out that surface comparison, something you might notice, let me turn on those nominal points, surface points, V for visible. Pretty much everywhere where I've built that point, you're seeing little to no deviation on the part, and that's because it's using those to restrain that area. So this is what it should look like. Looks really good. We have a lot of color range throughout the entirety of the part. Let's switch to our pre-alignment just to kind of see how different it is. This is our overall just global best fit. And then we also have our local best fit in the M in this one as well, which we've seen yesterday. With RPS alignment, it's definitely a strong alignment. I would say that it can be catered to most prints, and this is going to be an alignment you're going to want to be in when doing more in-depth inspections. Cool. So as you saw, we created those surface points on the CAD, and then we applied the measuring principle intersection with mesh. This is kind of an example I didn't show, but they just created a deviation label and dropped it right by where that point is, just to kind of show you that that area is experiencing very minimal deviation. So dropping those in the RPS alignment using this insert selected elements, and then just double checking that all of our directions matched the names that we gave them. This is just a way to be able to keep it very clean and clear in your software so you don't get yourself confused as to point directions. Cool. So you can apply checks, just like we saw before, to all of those points in the X, Y, and Z direction if you want to know the exact deviation from nominal that they're experiencing. So this is an example of that deviation when you're in what I'm assuming is probably the pre-alignment, as opposed to when in the RPS alignment, the deviations are going to go to 0 because those are the points that it's being locked to. Okay, I'm going to now dive into the software. Let's say we don't have CAD and we want to inspect just our mesh alone. I'm just opening up a new project in the software just because I don't want to disturb the one that I've already been working with by deleting out the mesh. And then grabbing from my exercise folder 1 under scan data, just the mesh and bringing it in. Saying new part. And the software automatically created a project for me, as you saw. So now we have our mesh in our project, which isn't lined up in any sort of way, which makes it really difficult to create nice report pages. It makes it difficult to check in directions. So we're definitely going to want to make sure that we have a nice, clear alignment. This is going to be just an alignment to itself for coordinate system use only. And to do that, we're going to drop down our initial alignment. Pre-alignment isn't useful here because we don't have CAD, but instead, we're going to use this 3-2-1. This is very, very similar to our RPS alignment in the sense that we're using our plane line point, which you can choose the rule. You can leave it Z, 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 Y, Y, X, or any variation of that. And then this requires no prior constructions ahead of time. It allows you to just build those points right away. So if I hold Control, left mouse click, creates a point in the Z surface. It moves the little arrow down to the next box for me. So it allows me to just really quickly, bam, bam, click between those points. Now we want to build the points on the Y. We're going to do it just like we did the RPS. 2 on the Y, perfect. And then we'll do another one over here on the X. And then once we have all of those in, you'll notice that those little preview cubes of the vectors kind of show us, and we can adjust this too. I can change the plane positivity on the Y. If I want this to be positive, I can change this on the X. So there's a lot of variations you can do with this as well. And once you're happy with the parameters of that alignment, you can click OK. Now, my part can square up to my coordinate cube just like it could in my prior inspection space. Cool, so kind of as you saw here, if you want that coordinate system to show up, just click F9, I think it is. Let me go back in and double check. I don't want to give you guys false information. F10, sorry about that. F10, and then F9 takes it away. So F10 if you want that coordinate system to be visible there. Awesome. Okay, just one last thing to wrap up today's training, and then we're going to get into the Q&A, and that is some inspections on this mesh with no CAD in my project.
Hey, Maddie,
Yes.
could you show what it looks like when the line's not positive for that 3-2-1?
Yeah, so I won't be able to go back in and edit it just because I don't have the parameters. So I'm just going to build a new alignment. So I'll go to operations, alignment, initial alignment, and then that 3-2-1. Cool. So let's make those 3 points again.
And just show what the result is with the line positive and then without it.
Yep.
Good.
So you can see that just kind of toggled the difference in the coordinate system here. So this would be without adjusting any of those positive, negative, and then this would be, oh wait, did it not make it? Yeah, this one. Let's go back, hang on. I guess it's showing up as the same here. Let's go back in here. Delete this. Let's edit the parameters of this. Okay, so this one I had the Z plane checked as positive. So if I uncheck this, there we go, that's a better representation. You'll see now the Z is in the negative direction, which is totally fine because I can still square up. It won't let me click OK on this just because that's a professional function. But I can still click this side of the Y, even if it's not the side that has that technical arrow on it. So, but just keep in mind if you want to keep specific to a print, that you can adjust the directions of these lines. And with this coordinate system arrows in view, you'll be able to see it. Awesome. Okay. So let's make some basic inspections like we did when we had CAD. So starting out with our construct menu, and then going down to the very basics, which is a cylinder. So we aren't going to want to use auto cylinder because we don't have CAD. But you'll see if I go all the way down to the bottom, there's a fitting cylinder. And there's one of these for a cone, for a sphere, for pretty much any of your elements that can have that measuring principle fitting element. There's the option to just build your own fitting element. So we'll go to construct cylinder, fitting element. The software is going to ask you to Control F mouse click again where you want to build that cylinder. And you'll see this window might look very familiar because it's exactly the same as the measuring principle window because you're given the same options here as well, except you do have a choice here. This is a slightly different, which is just your based on selection. If you wanted to use a nominal element, you would do so here, but we don't have any. So we'll just create that. We'll create another one here. Create and close. And you'll see I have no errors, nothing telling me to make any sort of additions to this. I can just go right from here into checking. And we'll do diameter checks. So here's where you'll notice a little bit of a difference. Against fixed value is now your only option, and it's default set to 0. So it doesn't know where to pull these values from. So the way that you're going to have to fill this out would be using a print. If you look under that folder 1 and then under nominal, there is a GOM drawing in there. If I show you that really quick, you'll see if you have a drawing and a mesh and no CAD, that's completely fine. We can reference this drawing here and use this 60 plus or minus 0.1 millimeters as our fixed value. Looks good. And we can do the same thing over here. Apply that check, diameter, pull back up. This is 75.47 plus or minus 2. And now we are getting a similar outcome to if we would have had the CAD with just a little bit more work. Similarly, we can inspect something like, let's say, the cone. Go down to cone and fitting cone. Cool, so you'll see this kind of red, which is the points it's using for that data selection. And as I zoom in, you'll notice it's leaving a little bit of a border around. It's not getting too close to any of that edge data. Create and close. And this one, we don't really have many checks that we can do with it, but looks good. Okay, so as you saw us do that inspection without CAD on the cylinder there, we just went right from construct into cylinder and then created a fitting cylinder with that construction fitting cylinder window looking really, really similar to what we've been seeing in our measuring principle dialog box. And then we checked it. They just left theirs to 0, but we've just opened up the print and typed in that value manually. They did the cone as well. They went ahead and checked that cone angle there. So as you can see, it's pretty much the same process as you go along. You're always constructing and then checking, no matter if you have CAD or not. There's just one intermediate step if you have CAD, and that's just applying that measuring principle. So great job, everyone, today. I know we kind of went into some in-depth topics. So our iInspect wheel, just briefly introducing measuring principles, constructing on our nominal. We built that outer disc caliper. We built a nice 2-point distance. We briefly covered construction of 2D elements like those circles and those angles. We created those surface points, talked a little bit about the measuring principles that are required for points, created an RPS alignment, and then just very briefly dove into inspection if you don't have CAD. So tomorrow, you can expect to learn about GD&T, as well as some custom report pages that you can make. And then at the very, very end, I'll actually plug in my license. So I'll have the professional version up, and I'll just give you a preview of some things you can do if you're working in the professional version that you're limited to not be able to do in the free version. Well, thank you for joining.
All right, everybody. Until tomorrow.
We'll see you tomorrow.
Okay, hello everybody, and welcome back to our GOM Inspect 2020 virtual training. This is day 3. So once again, my name is Maddie. I'm going to be your trainer for today. So I think we can go ahead and get started. Hopefully everyone can hear me all right. So just that quick introduction, my name is Maddie Badke, an application engineer from our Farmington Hills office in Michigan. I'm coming up on 2 years with Capture 3D, and we also have David Helton here. He is our host. He's also going to be answering your guys' questions in the chat along the way. Something you might notice a little bit different from yesterday, Dave's name is not going to be David, it's going to be Capture 3D. So if you see a response from Capture 3D, that's David answering any problems you might be having. And remember to keep your questions, which looks like we already have one, in the Q&A portion, keep them separated from the chat. That way at the end, we can filter through all those questions really easily. And then, like I mentioned yesterday, we are going to have a guest speaker today. Wade Smith is one of the lead application engineers, again, in our Farmington Hills office in Michigan. He's an expert in sheet metal within GOM and has been with Capture 3D for 5 years, but he has over 25 years experience in metrology throughout various industries. And he's also going to be helping us out in the Q&A session at the end of today's training as well. So if you registered for this class and you've been here since day 1, you are going to receive a certificate of completion that's going to have your name on it, as well as being signed by me. And those will get emailed out to you guys under the email you used to register. And give us, maybe until mid next week to be able to get those. And again, if you didn't register through the day 1, contact us at this training at Capture 3D so we can get that certificate issued for you. Let's start out by just recapping what we learned yesterday. We started with that iInspect wheel, that intelligence wheel that we've been using to make our measuring principles and our checks thus far. So with that introduction into measuring principles and the typical workflow from a project start to finish, we constructed our nominal elements. We built that outer disc caliper, a couple 2D distance creations. We practiced a little bit with constructing 2D elements like circles and those angles. And then we also created surface points, which we used for a more in-depth main alignment, that being the RPS alignment, and very briefly just covered inspecting if you don't have CAD, just directly onto the mesh. And on the agenda for today, we're going to start out with some basic GD&T creation, and then I'm going to dive into a really cool feature we have in our software, which is the GD&T quick creation. From there, I'm going to briefly go over some reporting in the free version of the software. And Wade's going to come in and he's going to give you guys a little bit more of an in-depth demonstration on how far you can take this reporting in the free version of GOM Inspect. And once we're all done with that, the last thing for today is going to be diving in to the GOM Inspect Professional. I'm going to plug my license in and kind of just bring up some sample projects to kind of show you what you can accomplish with the professional, how it's different than the free version. And then we'll wrap up the day with a Q&A session as always. Another reminder, you're going to see me polling projects from this folder. Here's the link if you need to re-download it for today. I'm going to be using this folder number 2, results and completed projects. If I open that up, right here, and if I go under this number 2, results, I'm going to be using this day 2 nominal element creation project. That's just going to take me right where we left off from yesterday's, sorry, let me drag this back over here, from yesterday's projects so that we don't have to backtrack at all from what we went over the first 2 days. And this project folder number 4, that is going to contain all the presentations and daily recordings for you guys to be able to go back and reference later. And Sonia told me to let you guys know that this folder link will only be accessible for the next month, and then it will expire. So make sure at the end of today, and once we're done uploading into those folders, you download that permanently onto your computer so that you can access it at any point. Because if you wait and try to open that up back to this link a month from now, you're not going to be able to get into it. Cool. So with that being said, we can go ahead and dive right into the workspace, our project. So like I mentioned, this is this day 2 completion project. It contains everything that we've went over the last 2 days in our trainings. So if I open up my Explorer window, you'll see I have my CAD and my mesh, some familiar inspections like our surface comparison, material thickness, some dimensional checks here, as well as all the report pages that we've kind of talked about. So again, just to recap, I'm in the inspection workspace within the GOM Inspect free software. If yours looks different than mine, that's just because you're in a different workspace than me. Remember, the purple is our reporting and the orange color is our inspection. So let's talk about GD&T. So GD&T in the software is really quite easy to check. I'm going to start out by doing it the long way, of course, and then I'm going to go back over everything we create the long way and show you kind of that shortcut function using the GD&T quick creation. So going into construct, remember from yesterday, we use this construction menu to be able to build all of these nominal elements. We're going to do the same exact thing today, starting out with an auto cylinder, just to keep things really basic. The GD&T inspections we're going to do first are going to be just more form-based GD&T checks, and then we'll dive more into the position-based ones from there. So having this auto cylinder dialog box up, remember to pay attention to your mouse keys required to be able to make this creation. This is a control left mouse button creation. And I'm going to grab a cylinder on my project. So let's start again with this upper left cylinder up here. It's auto naming that for me cylinder 5 because we already have 4 cylinders in this project. Once I'm happy with that cylinder creation, I can click OK, maybe make another one around this O. So now that we have a couple cylinders in our project, remember this little door is our create and close. You don't have to use that. You can go back over this dialog box, create and close it out there as well. From here, if you remember from yesterday, we have to apply measuring principles to these nominal elements so that we can get that nominal element's actual element counterpart. Accessing that iInspect wheel by clicking the iInspect wheel button in my upper toolbar here, or using that control right mouse button, and it will snap to wherever my mouse is in my 3D view. So now that I have both of these not selected, I'm going to hold control, make sure I have both of those highlighted, because I can apply a measuring principle to more than one element at a time. Opening up my measuring principle dialog box and applying a fitting element. Again, not really paying attention to these more expert selection parameters, and instead just practicing, that this is this Gaussian best fit and that we're using about 3 sigma of the point data, and choosing OK. So from here, yesterday, we moved down our iInspect wheel into this check quadrant. We're going to skip over that today and keep on moving over to what you can see here is our GD&T checks. So kind of similarly to what we've seen before, the iInspect wheel kind of contains some checks that we can apply to these cylinders. And for this sort of check, the easiest thing to do would be like our cylindricity check. So let's go ahead and apply that cylindricity check to these 2 cylinders. Again, because I have both of them selected, it's applying the cylindricity check to both. All we have to pay attention to in here is applying a tolerance, which might be coming from a print or might just be based on the geometry. I'm going to use about 1/4 of a millimeter for today's example. Go ahead and click OK. Now you can see we have some GD&T checks in our software. So we can do the same thing again. This time, let's construct a plane. So we'll go into our plane, and we'll grab this auto plane nominal. And this time, let's inspect this upper surface of these 2, this cylinder and this cone. We'll create a plane there, clicking create, and then a plane here as well, going over to my door to create and close. These 2 are going to get our measuring principle once again, fitting element, clicking OK. And then they're going to get to the GD&T check for flatness. So hopefully all this is kind of making sense so far. We're kind of just sticking with that creation process that we saw yesterday, but instead checking GD&T instead of dimensions. So this check might work great for you. You might say that's all I need, but we can take this one step further and actually display this GD&T check as a color map. So I'll show you how to do that by clicking the label that has this little cylindricity or flatness icon. Once we have that highlighted, I'm going to click Tab on my keyboard, open up the parameters of that. I'm going to go down to Display. You'll see right now the tolerance zone is being showed. If you're wondering kind of what this section is, this blue that you're seeing around the section, if I actually zoom all the way in, you can see this kind of inner and outer tolerance that's being displayed for me. And when I zoom out, you can't really make a big difference about what that's really showing you. I'm just going to go ahead and check that off. We don't need it. And instead, I'm going to turn on the show color deviation, right? And from there, you'll notice we want to make this cylinder invisible. And we'll want to see again. go back and turn my CAD on here. We're going to go up to this other cylinder. Open up my cylinders here. Geometries. We'll turn on this cylinder up here, as well as that cylindricity check for cylinder number 5. All right, cool. And we'll do the same thing over here. We'll turn off that tolerance zone, and we'll turn on that label, as you can see there. We'll do the same thing for our planes, going into, I think it was 3 and 4 we created, as well as grab those planes, turn on those flatness checks. I'm using my related items column in this bottom sub explorer to find, so I don't have to dig through all of these inspections in our explorer. Go in here, we'll turn on the color deviation there, and then we'll do the same for this one. Awesome. So now that we have all of these color displays, I can go ahead and play around with the legend, similarly to like we did yesterday, editing this maybe to make it slightly smaller so that you get a little more color variance through. This one here is kind of a great example of that flatness. If I turn off that plane, you'll see that we're getting really good color representation here on those flat planar surfaces, and we can drop deviation labels on those as well. So again, holding control, I can kind of hover over this and place some deviation labels on there to kind of get that good representation. Maybe I'll square this up. We'll turn off our cylinder checks, and we'll make a report page of this flatness checks. Save that view for later. Cool. Now let's talk about if we wanted to do a GD&T check that might require a element to be built prior. So maybe we're doing a position check that's being called out to a datum. All you have to do is ahead of time create that datum that you're going to be calling out to. So let's say this left edge here is our datum. We'll construct a plane over on this datum, or on this edge, right? And just to keep the naming clear for ourselves, instead of just leaving it as plane 5, I'll call it datum A. Great, and close. And let's give that measuring principle fitting element. Great. So now with that datum called out, let's bring back up these cylinders, the cylinder 5 and 6. And let's say we want to check these cylinders' position to this plane datum A. I'll grab the header of both of my cylinders, using control to select both of those, going to GD&T, and then I'm going to use this position check here. So this window is just slightly more complicated. It's requiring you to select a datum system. For this, we're just going to use our datum A. And then manually applying that tolerance, whatever it might be from our print that we're matching, and then clicking OK. So you can kind of see those position checks now are just found right underneath those cylindricity checks. Maybe one datum isn't enough. Maybe you have a datum system you need to be checked to. I can show you how to do that as well. If I go back in, we'll construct 2 more planes. And remember, when you're doing your datums, that these planes have to match up to the datums that are on your print. So this is all just very theoretical right now. But I'll make another datum maybe on this surface, and maybe this is datum B. And then maybe this edge over here is datum C. we'll make both of those fitting elements as well. And now with our 3 planes that we know will lock this part in all of our degrees of freedom, I'll go from construct all the way down to local coordinate system, over, and then down to create this datum system. From here, I can choose my datum 1 to be A, B, and then I must have named the C1 on accident, and that's totally fine. And keep in mind, this order matters when creating your datum system. So make sure that when you're naming this ABC, that it's following the exact order of whatever your print is requiring. And it's letting me know no more degrees of freedom. We can create and close on that. And now I can do checks. We'll just turn this invisible for now just because it's a little distracting. We'll turn off all of our datums. Oops. And maybe let's create a new cylinder. We'll construct an auto cylinder down here. Cylinder 7, create and close by measuring principle of fitting element. And then let's check this GD&T position. And under datum system, we'll grab that coordinate system we created, ABC, and we'll check to that. So just to kind of show you guys how that's possible within the software at a very basic level. Now that we've kind of done things the hard way, I'm going to grab my CAD and drag it out exclusively. And I'm going to show you guys a really cool function in the software, which is our GD&T Quick Creation. That kind of does all of what we just did, but in one easy click. So up here, this little drop down, you'll notice if you hover over it, it says GD&T Quick Creation. From here, we have lots of options of things we can construct. Let's just start off with flatness. So this is a little bit of a longer dialog box. You have some options here. If I hold Control and hover, it will show me a preview of that element I'm going to create. So this would be this flat surface on the block. I come over here. It's telling me I can create a plane here. I can create a plane here, of course, over here, and on this bottom surface as well. So let's create 2 planes, maybe here and here. So we'll create this plane using Control F mouse click. You'll notice it took me right to the final step of GD&T check, which is applying a tolerance. So kind of behind the scenes, the software constructed a nominal plane, the corresponding actual plane, and then brought me right into this check flatness window. So it took out 2 of the 3 steps that we had to do last time when constructing our GD&T checks. Clicking OK on that. This window isn't closed out yet. I would have to click Escape or right mouse button to cancel out of this window. So I'm still in that flatness check. So again, I'll try one again over here. Bam, it created that plane for me. It created the actual plane and brought me right into that flatness check window. We'll say OK. Now I'm going to click Escape on my keyboard to get out of that dialog menu. Let's try something else. Let's go down. We'll do cylindricity. Again, same window. It's going to tell you to hit Control on a cylinder. We type in a tolerance. We click OK, hovering around at all the different places that we can apply the cylinder check. Right? We can do one maybe to the outside of this letter G. Looks great. And then right mouse button that time, I did to escape. Cool. So some things you might notice in here if I click something like parallelism. I can check parallelism, let's say of this side of the M. However, it's going to bring me into my menu and ask what I'm checking to. So if I don't have my element created prior to this, you're just going to want to make sure that before you do that quick creation, you go into your construction menu and just make that auto plane or that datum. Let's say our print is calling this datum D. You want to make sure that you have that constructed prior to being able to, it says no, construct plane auto. Fitting element. Getting an error here that's saying the points do not result in a plane. So that's fine. We'll just grab something. We'll grab maybe this edge over here. Like that. Construct plane. About this one. Looks great. Okay, so now we have this datum D. So let's go into our create menu. Oops, clicked way too quickly that time. Go down to our drop down, check or create this parallelism GD&T call out on this surface here to our datum D. So maybe not a very good example here. These two surfaces might not be parallel to each other, but just to kind of give you guys the idea that you just want to make sure that you have some elements that require other datums built prior to those GD&T creations. And then the final thing I'm going to cover is using this create datum system here. So if I click this create datum system, you'll notice it's the same exact as when I went down through the construction menu. And last time I built my planes prior by making nominal elements, and then I just found them within this menu. There is another option. If you come over here, you'll say create fitting element is next to this box. So if I click this create fitting element, I can actually just create that plane right within that menu. So I'm going to kind of run out of datum. We'll just allow it to be called that plane 8 because I'm going to run out of those letterings. But just letting that be plane 8. Now going down, making this plane over here, plane 9, and then finally this fourth plane, or I'm sorry, third right here, plane 10. Looks good. So that was a super easy way to create a datum system as well without having to make those planes ahead of time. So we can create and close, and you'll see it automatically names it using the naming from these datums here. Cool. Opening back up my presentation. We'll just kind of talk about what we just learned. So starting out with that basic GD&T cylindricity check, constructing auto cylinder on a cylinder on our part. And then from there, applying a measuring principle, just like we did yesterday, fitting element, and then using the GD&T cylindricity drop-down menu and applying a tolerance. Similarly, to do a flatness check, we have to construct our nominal plane first, select an area on the part that we want to be our plane, applying a measuring principle fitting element, going into our eye inspect wheel, selecting that flatness check, and then finally applying our tolerance and clicking OK. We went over reporting that GD&T, and one of the cool ways that you can use a local color plot to display that deviation. So clicking that lower part of this flatness label on this plane, and then opening up the properties on the right, clicking tab on the keyboard. And then under this display category, you'll see we turned on the show color deviation representation and adjusted our legend to match that we got a good display of colors. But as you saw, there is a faster way. So using that GD&T quick creation menu, we could do all of these steps in one click. And then using that camera icon to take those snapshots of the 3D view to save them for reporting later on. Okay, so hopefully that covers basic GD&T inspection for everybody. From here, I'm going to open back up my project and we're going to continue on with reporting. Okay, so if you remember, reporting is this workspace below our inspection workspace. And if I click on this, it will bring me into my new workspace. It's displayed by this purple bar at the top. You're going to see this first category here is all of your report styles. So without clicking anything when creating them, you'll notice that all of my projects, or most of them, were done using this A4 style. This is kind of, because this is a German software, this is a European style, something you might be more familiar with, might be letter, whatever you want to use. All the styles are going to be within your software when you open them. So picking a style we want to work with, let's say we're going to work with letter, and opening up, you'll see we have quite a few templates to choose between, from title, table of contents, and then all the different 3D views. So let's just kind of see the report pages, which are found down here that we have in our project. We have a title page. We have a CAD, just a quick picture of what that looks like. Our scan data, a mesh detail report page, that alignment, that pre-alignment, a surface deviation, that local best fit, surface comparison, a section cut of that inspection section, material thickness, we went over that, some diameter checks, some distance analysis. So this is a pretty full report page, as you can see. So let's kind of talk about how we can edit these and what abilities we have in the free version. Something very easy you can do is move these report pages around amongst each other just by clicking them and dragging and changing the location of that report page. So after the fact, we can do this. What you can't do is open back up the parameters after the page has already been created. You'll notice it would say this is just a professional function. But a workaround from this is going to be all the way up at the top here. We have restore 3D view from report page and overwrite report page. So this is going to be from our inspection workspace, whatever we have visible. So since that report page specifically is just a picture of the CAD, I'm going to grab my CAD, display it out exclusively, set up a nice view of the CAD, go back into my report workspace, making sure I'm on that CAD report page, and then saying overwrite. And you'll notice that overwrote whatever my view was in that inspection workspace. So that's kind of your workaround. Instead of being able to do it all within here. So like in the free or in the professional version of the software, you can even open up your Explorer on the left here, play around with things, but of course we aren't able to manipulate this because this is the free version. So something else we can do is change the style. So this report page here is our, what style is this? Tell me. Section style. Well, so in our report masters, you'll see the two styles in our project currently are A4 and A3. So we don't have any letter style. So we'll overwrite with that. So if I grab the title letter style and then drag and drop that over top, you'll see it updated to that letter. And all this is really page sizing. It's not really formatting. And now under our report masters, you'll see we have that letter style. So depending, you can have multiple styles within your report, but keep in mind that your masters, which is where you have some more manipulation just kind of with the layout of all the pages, maybe the imaging and stuff in here, which I'm sure Wade will go over when he does his reporting in detail. We're just kind of covering the basics right now. So you're able to switch them over like that, as well as edit or bring in, let's say we'll bring in a table of contents. So we don't have a table of contents yet in this report, so I'll drag and drop our table of contents after the title page, but before that first CAD image. And I'm going to name this right here, table of contents. So something cool about table of contents is it automatically populates for you as I move things around within my report. It will update here as well. You'll notice these two now flipped. I can move it back. Oh, I brought it all the way down to the bottom. Back up. Right after the table of contents. There you go. So this updates automatically for you. Something else that you might see is in our title page. You have to fill these in yourself, but it doesn't allow you to type in here. That's because these are keywords in our project. And you access these by going up to the key file. So defining project keywords. From here, I can type in all the information about this project that might be required, such as who the inspector was. If I could spell my name, that'd be perfect. A part number, location, all the way down. So basically keeping in mind that these are kind of scripted throughout your project, and that's why you aren't able to just manually type in. And this is also a way when we talk about project templates at the end of today's training that we can save this information is by using these project keywords. Awesome. So we've talked about overwriting report pages and we've talked about defining keywords. Let's go back to this first icon here, which is restoring a 3D view from a report page. And that does exactly what it says. It just brings you into the inspection workspace and into whatever view that report page was taken in. So let's grab something with a little bit of interest, maybe like these diameter checks. And we'll click this Restore 3D View. It brought me now into my inspection workspace and right back to that exact inspection. So this is an awesome way to be able to go back in, edit some things. Maybe I want to change kind of how these labels look. Maybe I want to turn on a few other inspections. And then when I'm happy with it, I can go back into my report workspace, go down here, and then, right, I could overwrite that. So I made it worse, actually. I'm going to undo that. But that's just kind of the ease of use, and that's kind of the workaround for the free version. So you'll see right here, this is how we export within our reporting workspace. So once you're happy with all of your reports, you can go to this export. It looks like a little Adobe export as PDF. From here, you'll be able to say if you want it to be all report pages or just selected the quality, and then if you want it to launch as a PDF after you export it. That's kind of your choice, and then where you're saving it to. Okay. And another thing I want to cover in reporting is actually the presentation that's possible through the software. So as you see, if I drop this down, I have the option to start from beginning or from a current slide using F5 or Shift F5. So let's start from beginning. You can go ahead and click here to make that presentation full screen mode. But I'm just going to go down to another view within the software. So let's say we're presenting our scan data. to maybe a supplier or a customer, whoever it might be, and they have a question about the coverage of this. You can actually click this interactive 3D view, and this allows you to move your part around within the presentation workspace. So this can be really handy. I can zoom in on it. I can move things around. So this is great while you're talking about this report, that you can interact with it and kind of get a more use out of that report than just that one still image. Of course, restoring the 3D view or resetting the view, whichever you want to do. Going through all the reports. And then the last thing in this presentation mode I want to talk about is the difference between exit presentation mode and this big ol' X here, which actually closes the project. So make sure you're not clicking this X unless you want your project to be closed out. If you want to close the presentation mode, make sure you're clicking this presentation mode here, or escape on your keyboard, either one. But just keep that in mind so you're not closing out your project, because I have done that many a times. Okay, so that's pretty much everything in the report workspace that I'm going to talk about. So I'm going to jump back into my presentation. Okay, so as you can see here, we have to, of course, switch to the report workspace before we can do anything else. And that just requires dropping down this menu here and then moving down to our report workspace. Within here, this kind of lays out the just default layout, and all of this is manipulatable, sorry. So you can actually move these tabs around kind of wherever you see fit, but this is default, starting with your report styles up here, the report pages you constructed, the 3D view of that report page, and then the properties of the report page. And then down here are your kind of toolbar so that you can make changes or edit report page templates. As you saw me do, a cool function in the software is this kind of drag and drop, which you also see me do probably quite often in the inspection workspace from my Explorer tree. So same principle here. If you grab that title and drag and drop it down into the project, it will create that title page for you. It's automatically going to toss in whatever 3D view you have currently in your inspection workspace. So to be able to edit that, if you want it to be, of course, different, make sure you have what you want visible up before you make that creation. But you do have the ability to still edit moving that kind of part around. Using this icon here to toggle between portrait and landscape, and this one here to switch between the report style. We defined our project keywords using the little key icon. It can also be found if you drop down this edit menu. There's a edit project keywords in there as well. You go ahead and fill out any information that you see fit as far as what was happening with the inspection there. Maybe the version the system used could definitely be a useful one to store that, so you can keep track of, if you have multiple scanners, which scanner was used to collect the data. Another thing you might notice is that the set as default option is only available in the professional version, and that just kind of goes along with those project templates where you're able to kind of save some information in the software, so every time you open it, you kind of have these defaults already set for you. And this actually goes under packages, which we're going to talk about in a minute too. So adding a table of contents page like we did, and dragging and dropping that down, changing the orientation if needed, which you can do here as well. You'll notice if you click these landscape to portrait options before you drag and drop. That's another way to manipulate what that page layout is going to look like. As I mentioned before, Wade is one of our lead application engineers here, and he put together a presentation for you guys to kind of go over reporting in the workspace, and I think a few other little inspections. So before we dive into his presentation, we're going to take our quick break first. So this is just like a quick 10-minute break. So around 1:55, we'll see you guys back here, and we'll hear from our expert, Wade. So thank you guys so much. Is everyone doing okay in the comments, David?
Yeah, we just have one question we want to show. I don't know
Okay.
if we want to do it now or if we want to save it until the end.
Yeah, we can just save it to the end, but what is it?
He's just wanting to know the distance between at the top of the GOM block, that cone, the conical area, and the cylinder inside, just the distance between the inside diameter and that cone.
So the thickness?
That's one way to check it, yeah.
Oh,
You
okay.
can do that,
Yep.
yep.
Okay, cool. Yeah, we'll just do that as an example at the end
That's
for our
fine.
Q&A portion. Cool. Okay,
That's fine.
well, we'll have you guys back in 10 minutes or so. So see you guys soon.
All right. So as Maddie mentioned, I'm going to go over some reporting that you can do in the free software. It's pretty extensive. I know she said I created this, but I got to give credit where credit's due. Our colleague Darren Marsh, he did a really nice job putting together it's a full report based off of the print that you guys got in your package or your download. So we'll get started with it. Some of the stuff's going to be stuff that Maddie kind of covered already, you know, like the table of contents, title page, that kind of stuff will be repeat type information. But so here's our title page. Here's what it looks like when the keywords are filled in. So we went ahead and put some arbitrary information in there for us. Here you can have any image that you want, whatever you pick from your 3D view would go here. And then of course we got the table of contents. Maddie already talked about the fact that it's a live document basically. So as you move some of your slides around, or even if you rename them, this automatically updates. So that's a nice time saver that we don't have to go back and rename a page and then rename it in the table of contents and so on and so forth. So just some of the stuff that we could show in reports. Obviously, you can look at your scan data. This particular scan was 709,567 points. Here's a zoomed in area with the mesh structure on. The mesh structure shows the triangulation of the processed data. Up here, you'll notice this is a picture-in-picture. The little highlighted area is where we're zoomed in at. So you get a better overview of what you're looking at. Sometimes it's a little difficult when you're zoomed in to be able to know exactly what you're looking at. And if you notice on the mesh structure, triangles get smaller and tighter together when we have a little bit more pronounced geometry than we do on the flatter, smoother surfaces. So here is, we've got a color map on our part. We've got our points that we've defined for a 6-point alignment or a 6-point nest or an RPS alignment. So we have a Z1, a Z2, a Z3. We've got a Y1 and Y2 and an X1. And if you'll notice, down here at the bottom of our report page, it says pre-alignment. This is our global best fit alignment. And we're looking to see what type of deviation we have in our datum points. So you'll see we have deviation in Z. We have deviation in Z. We have deviation in Z. Also, we have it in both of our Y points. We have a little bit of deviation in X. So that's showing us from a global overall best fit how close our datum points are. Then we'll switch to the datum alignment, our RPS, or 6-point. You'll see that because we're in that alignment, we've zeroed out on all 3 Z points. We've zeroed out on the Y points and the X as well. And you'll notice that the Z direction is bold. So we've picked these 3 points. They're leveling, the 2 Ys, which we've rotated to, are bold, and the X. That's what we define them as in our RPS. So that's a pretty powerful tool. You can prove to your customer that your alignment points are good. We have 0 deviation. So that means we're aligned to the datums as intended. So here, you guys have seen this a few times. It's a standard surface comparison. Here again, we're in our pre-alignment. We have a few deviation labels. Just keep in mind the deviation is the deviation. We can adjust our legend to adjust the color representation for a visual aid, but these numbers don't change. So here's the same deviation labels, but we've just moved to what we call a GOM 3-color. So this legend has been set up to say, or to show us that anything between plus and minus 0.25 is good, regardless of what the value is, as long as it lies between those two. And then anything outside of that, on the plus side being red, up to 0.35, and the minus side up to minus 0.35. Another way to visualize the same information. And then here it is as a pass-fail. So you've given a certain amount. It's good. And we have an area that we consider a warning that's getting too close to our out of tolerance. And then obviously whatever is out of tolerance. Now with the color map, with this type of pass-fail, we don't know if it's plus or minus. That's why we'll look at the deviation labels. So here is an inspection section. By default, the software labels it with what plane, where at from 0 it was taken. Of course, this one has equidistant deviation labels. They happen to be created 35 millimeters apart. So we have the same inspection section. This time we used our clipping cube to make part of the CAD model invisible so that we could more easily visualize where this is on our part. Sometimes your sections don't spell out a nice word that's easily recognizable. So we can use the picture-in-picture. Picture-in-picture shows the full CAD model, but our 3D view shows the top portion of the letters and the 2 cylinders up top as invisible. That way we can get a nice visual on the entire inspection section. There's a standard inspection section going across the part. And sometimes it's a little difficult there again to tell where it's at, although we know it's at plane X at 130 millimeters from 0. Still a little hard to see visually. So we'll use our clipping cube and we'll hide that part of the CAD. Makes it much easier to see where on the part we're looking at and inspecting. So here is second page of the GOM print. We're able to create a page and drop that in here so you can make that part of your report, which is pretty cool. Darren used Adobe Reader, and as long as your version of the Reader allows you to create circles, you could create a circle with the borderline in red, add a text box or a text comment, and you can insert the numbers, and then you can balloon your own prints. It should be a free version as well. I think this is actually page 2, but they're both labeled page 2. So here's a report page showing the datum system that was created using the quick GD&T creation. Sometimes that's nice to show customer that you're properly aligned on the part to those datums. And here we have some of the balloon numbers. So we're showing balloons 1, 2, 4, and 5. These checks are linear size. So it's showing the largest and smallest amount of a 2-point distance. And then of course, on cylinder 2, we see the true position to D&E. Cylindricity check, and we're utilizing a color map with our max and min labels. We get our color representation. So here's another example of some basic dimensions, but in this case we've changed the transparency and the border lines of the CAD model to make it a little bit easier to visualize where the checks are coming from. And we've also used these leader lines, which I'll show you in a few minutes how to use those. Balloons 8 and 9, there's parallelism and an angle check. Parallelism of this surface or plane to your datum C. Calls out parallelism of within point 2 to C, your actual value, and then an angular check, this leg to this leg. So here is the top of the M. This is surface profile. And what we're showing here is we're showing there is no datum system call out, it just shows surface profile. When there's no datum call out, get a form only. If there was a datum, it would check form and location. So then here's an example of showing the measuring principle of the projected offset section. With the distance to the element, how far offset it's going to cut a section, and the width at which it's going to sample the surface data. And of course, it says that it's outside. Here yesterday, I got mentioned that it's difficult, or you really shouldn't check a distance between two planes. Normally, you don't know where an individual point might be You're just getting a 2-point distance. That was with the caliper check. But here's an example of how to check between two planes. It's from our quick GD&T. It's called linear size. And what that does, that gives us a nominal width between the two planes, but also gives us our maximum distance and our minimum distance. That's a pretty cool check. Typically with a CMM, if you came down and touched a point, that's the only distance you would know, but it may not be the information that you're looking for. And I'll show you how to do that one after I finish going through here. Just some more basic checks. Flatness call out, showing it from a side view. So a couple of distance checks, flatness and a diameter. Here's some more of the same from the top view. All linear checks per the print. And then also get the 3D graphical area showing those linear checks, but also it can be seen here in a table. Like the visual look, and other people like to look down a list. So you can present it in both ways, all on one report page. Overflow. So there are certain ones that fit in this table. And then there's the second page. Here's a flatness check showing color representation with a min and max label. Some more parallelism checks. One plane had a true position call out. So you can do that in our software as well. So here's just a distance check on balloon 1. Point-to-point check. Showing it in the table with the nominal, the actual tolerance, and the deviation. That's it. 30 pages. So a lot of stuff we can do in the free version. We're not limited to just very generic inspections. We can inspect and report quite a few items. So let's start out with, I show you, so Maddie showed you if you click on the page, you could come up here and say restore 3D view, or you can right click on it, restore 3D view. It's my CAD model of my Golem block. If I click on that and make sure that's selected, I can always open my Explorer, make sure that's highlighted. If I hit Tab, I get our properties window. Also, if I mouse over to the right edge, I get these double arrows, and we can open our excuse me, properties window. You've got these different categories. We're going to use display, and here you'll see transparency. So sometimes when we want to see something, it might make sense to make this a little more transparent. That way the CAD isn't blocking part of our view. Also, sometimes looks a little nicer if we don't have the boundary lines on or the wireframe. So these are a couple of options you can utilize for different ways to visualize your report pages. Adding of the image of the report page. I'm going to go select down here at the bottom. And I'm going to right click and say create empty page. It looks like it's A4. And so after you balloon your print, if you use your snipping tool or save it as a JPEG, this is a JPEG, I could just grab that thing, drag it over to my empty page. I want to add it as a report image. There we go. We just have to have it saved as an image. It's as easy as that. Cool thing you can add to your report. The quick GD&T, linear size. So when we go to our quick GD&T, here at the top, if we pick linear size, software automatically wants us to select something. So if we click on that plane, click on that plane, creates a symmetry plane between the two. Make sure it's on 2-point size. And we want the computation method to be maximum and then minimum. You could set your tolerance. It's probably a little more than that. I don't know what it might be, but we'll go with 0.4. Say create and close. And we'll either hit escape or right click to exit that mode. Here's an example. We might use our transparency. If you'll notice this blue line here, so that's going to be our maximum distance, and then the two blue arrows is going to be our minimum distance. You'll see most of our deviation comes from the maximum distance. So pretty cool way to be able to actually check between two planes and know where we're getting our least deviation and where we're getting our maximum deviation, and just 2 points that always go to the same check, and we might be missing information elsewhere. That's a pretty cool feature. I think Maddie already covered it, but if we did say flatness, select the actual flatness callout, say show that the color deviation, and turn the tolerance zone off. And then sometimes it's a little bit better to show your color deviation on the actual. Sometimes the CAD hides it because it's going below the CAD. If we turn off the nominal and we go back and say choose visualization, go to the check, actually returns our label for us. We tell it to turn off the nominal, and hides it. So then we see the full nice color. It's on top of our mesh. And then we can also select that flatness, bring up our iInspect, hold down Control. What's our min and max? Here we got labels for min and max as well. So very nice tool, to be easily understood. Then we also got maybe look through here and see. All right, I'll do my own. So let's say got a couple of cylinders. If you select on your diameter, you're going to get this little blue square box in the middle of your 2-point distance. If you click and drag that a certain direction, you'll be able to extend the leader lines, show the the outside dimensions of the diameter or linear measurement you're trying to show a dimension for. At this point, now we have the dimension separated from the nominal, and we can make that invisible. Now, still a little tough to tell exactly where these leader lines are going. So here's another example. If we select our CAD over in our Explorer, do our transparency, drop that down a little bit. Now we can exactly tell that's on the outside of those two diameters. So that can be really helpful. There again, visualizing exactly what we're putting a dimension to. Another thing that can be really helpful is sections. I know Maddie showed you like an inspection section, but sometimes it makes sense that we want to have multiple inspections or sections, pardon me. So if we go to construct, we could go to section. You could do the multi-parallel, which I think Maddie showed you yesterday, which is going to give us straight line sections across the part in our axis, whether you're the X or the Y, Z, we'll go with the X. This position is going to be where it is off of 0. Say a maximum number, you can increase. We'll say select all. Anytime you move around, you're going to regenerate. 1.8 millimeters really close together. Probably wouldn't recommend that. 10. There you'll see you got multiple sections in straight lines. Select all that. You can also do them in a radial fashion. If we go back to the section, we got multi-section radial. So what this wants is it wants to base it around a circle. So if we have a known circle, I believe 14 is this one up here. So it's going to be this inner diameter. I can give it a start point. I can just say from CAD 0. If you look here, we've got equidistant radial sections. We could pick the number of them, depending on how much information you feel you need. Makes this not too cluttered. You could pick a starting point. For this one, we'll leave it at 0. This direction, how much of this boss or embossment do we want to cut a section on? So if we don't want it to go outside and over this edge, we can reduce it down so these green planes are within. Same thing with the height. So if I make these small enough, you'll see it's not going to the bottom of the inside cylinder. Or if we want to include that, we could extend it a little bit, go beyond that. We can easily right click and say select all points, or use your selection tool at the bottom. The reference construction. You can even make those exclusive. There. You got equally spaced out radial sections. And then you can perform whatever individual inspections you'd like to do on that. And then one last thing you could do, let's say we need information on the outside of this M, but we need it to go part way up into the curvature of the N. If we come up to construct, say curve, create an edge curve on the edge of this CAD model, and we'll click down here, just holding down Control. See, that way it's creating a curve up around the M. Say create and close. This one, don't necessarily need a measuring principle. We'll just leave it as a nominal curve. Say construct section, multi-section curve. I can hit the drop down, select that curve. And here again, we can change the distance between the sections. I don't know what type of information you think you need to see. And then also how big those discs are. So if we only want a little bit of the top, a little bit of the side, here again, we can right click and say select all points, create and close, and give that reference construction as well. Those exclusive. There you've got sections all perpendicular even as they go around the curve. And create your individual inspections on that. So don't be afraid to try stuff. This word professional will come up when it says you can't do that. But other than that, try to create as much as you can, because there's more than just this. This is just an idea of the power that the free software has. Oh, I want to show you one more thing. I'm done. Talked a little bit about the flipping cube. So in this picture-in-picture, click on a surface in that picture-in-picture. It allows you to use this cubical shape to make stuff invisible. So let's say we needed to see some information on the edge of this O, and the M is in our way. We can also, on the side view, whoops, we got to do it on the cube. Same thing. I can drag this until I take away whatever's necessary to see whatever we're trying to look at. Also bring it in, and we could pretty well isolate that O, so that's the only thing we're looking at. This is a really good tool for getting the right visual that we need to be able to see the inspection we need, and all we're doing is making portions go from visible to invisible. So really nice tool there as well. I think that concludes my portion of reporting. Hope everybody liked that. I think Dave will hand it back over to Maddie.
Yep. Thank you, Wade. Does anyone have any questions over reporting for Wade? Go ahead and ask in the Q&A.
Yeah, and we'll cover those answers
at the end.
Yep.
All right, Maddie. Thank you, Wade.
Yep, thank you.
All right, Maddie, it's going back to you.
Okay. Awesome. Thank you so much, Wade. That was really great, really helpful about reporting. So moving on from reporting, again, if you have any questions, we can cover those at the end in the Q&A session. But for now, we're going to dive into a little bit about what you can do in the in the professional version of the software. Sorry to move that little. That's my camera that was blocking your guys' view there. So yeah, as you can see, just going all the way from GOM Inspect Lite all the way over to GOM Inspect Pro, right? All the things that are kind of included. So all of them have reporting, kind of as we mentioned. Creating your own new project, the GOM Inspect Free does, of course. That's what we've been moving on with today. The GOM Inspect Lite, that's only to open up or access or look at a project that's already been created. With all of our versions, you can import your data in any of the basic formats, right? Something you can't do that we're going to talk about in the free GOM Inspect is this customization of packages, scripting. Parametric inspection is a really big one. That's the software storing the information it had when creating elements. You can go back in and edit that at any point you want. And this kind of parametric idea allows us to do stage projects, project templates, so on. So yeah, we're going to kind of dive into some of that information now. So as you've kind of seen from probably your own view as well as my view, both of our GOM Inspect had this little Try Professional button at the top. So if you go ahead and click that, that will be you requesting your trial license for the professional to be able to run it for 30 days for free. And that license file will be sent to you via your GOM ID email. So if that's something that you think you're interested in after this course, go ahead and send the request over from that to GOM to get your 30-day free trial. Let's talk about packages a little bit. So these are available in the GOM Inspect Professional as well as ATOS Professional. And they are a way to bundle all of our various templates. They're a way to share or receive templates within your organization or from off of GOM's website, as well as to enhance your software with new features that are coming out. These are some more detailed kind of topics, but we have like user-defined checks in your iInspect wheel, scripting, etc. And this is also going to be like more specific situations or uses such as like airfoil or sheet metal. So a lot of all of your packages can be found either within local folders, local network drives, or within the GOM Inspect site. And you activate them in your software by clicking the little package icon that's found next to the search bar. If you open this up, all of your packages that you have will be within there, and you'll be able to switch between them. You can have as many turned on at one time as you want. And those packages are going to store specific information such as like iInspect wheels, the project keywords, like I mentioned, reporting templates that you save. Really, there's just no limit to that. So I'm going to dive into the professional version right now. Just opening up a trend project I have in my sample data to show you guys for some basic trend analysis. So as you can see, I have my license plugged in. So this is just the professional version of the same exact software we were already using. I'm just going to close the table for now. I'll get into that in a minute. So as you can see down here, we have multiple stages brought in. I can switch between these to kind of get that various information. You'll see because these are trend labels, they move. The little crosshatch moves to tell me what stage I'm inspecting. So to get these multiple stages in your project, all you're going to do is drag and drop in those meshes, as many as you want at one time, and then you're going to add as stage. It's going to bring them in down here. Something to keep in mind, they share an explorer. So whatever you check onto that CAD gets applied to all of them. They can't have their own specific inspections, but what we can do that's really neat is actually, before I do that, first I'm just going to talk about these trend labels. So opening up that iInspect wheel and then clicking a label just for a demonstration. In the center of this iInspect wheel, you'll notice this little magnifying glass. If I click this, I can go down to choose visualization, and you'll notice all the way at the bottom, this trend is selected. So that's kind of what you're going to need to do to get this trend label to show up for you. If I open up my table, which we haven't talked about too much, and then I go over to that table template, you'll notice if I'm using this statistics trend option, that's showing me all of my inspections at each of the different trends. So this is specifically a circle position check and kind of what that value is at each of the trends there. So that's really helpful, especially if you're trying to notice which stage has that outlier point. Perhaps, sorry, my software is saving as a working copy. I have to let it do its thing. There we go. Okay, cool. So let's bring up something like our surface comparison that we're used to seeing. We'll grab and drop that out exclusively there. Okay, cool. So now as we switch between the different stages, you'll notice they're all in the same RPS alignment. Sorry, this project is in German. But if I switch between these, you'll see kind of how each of those change. If you're looking for more of a statistical analysis, I can actually right click on a stage and set it as a reference. And when I do that, that makes that stage almost take the place of my CAD. It's saying this part is perfect in the software's eyes, and everything else is going to get compared to it. So kind of see how it changes if you do it that way. So that can be helpful just to see changes from part to part instead of all of your parts being compared to the CAD. Going back in and unsetting that stage. Oh, sorry, that was disabling stage. I don't want to do that. Go back. And yeah, one was reference stage. Unset reference stage. There we go, close. Okay, another option we have is we can go over to our legend type over here, and I can play around with some of these statistical legends. Let's just say, for example, we'll do minimum. So if we do minimum, this is showing us the minimum surface deviation across all of them. So if I toggle between the stages now, it kind of makes sense that I'm getting the same results, right? Because it's just showing that one average amount from my statistical group. I can do the same thing for maximum as well as range or mean, right? So now it's kind of showing you some of that statistical analysis, which can be really helpful. One final thing we can do, let's see if they have this in the reports. With stage projects, nope, I'll make one. That's totally fine. So I'm going to set this back to my traditional legend type. Okay, we have all of our stages here, and this is our surface comparison. So I'm going to make a report page. I'm going to call this surface comparison there. And then you'll notice right here it says by image, but if I drop this down, I can actually change this to be a video or a flipbook. So if I say video, I can choose how many seconds it stays on each stage. Or sorry, this is just the duration of the entire video. If I click OK and then open back up the reporting workspace and then edit it in here, I can actually say how many seconds per stage I want it to be on that video. And then clicking play down here, it will run through each of those stages for you. So alternately, we can change that from video to flipbook. This is a little bit easier now for printing reasons. because it will store all of those different stages under that one report, and you can drop them down and kind of toggle between them this way. So that's a really good tool for reporting with stages. Okay, now let's say I have a part. Let's open up day 3 complete from that project folder. So pretty much we're going back to that GOM block now, and we're going to look at this project. Again, I have my license plugged in, so I'm opening this in the professional version of the software. So let's say this is a part we have to inspect often, and we want to save this as a project template. So the idea with that is, since all of the inspections were built on the CAD, and since the software saves that information and we can go back in and access it, I can actually file, save as. Oh, not save as, that's my fault. Let's go to the next one below. So that. File, create template from project. And by doing that, it's saving all the inspections within that project. So we can call this our GOM block. And then you can give a description as well about what this project template contains. And when we're happy with that, we can click OK. Now, if I go back up to my start menu and I open up a project template, I can grab that GOM block. Awesome, and you'll notice nothing's calculated. That's just because the software replaced my mesh in the project with just a copy of the CAD, so that I can bring in a new mesh at any time. Again, this is for parts that we're repeating similar, or we're scanning the same part, but multiple parts, right? So we can drag and drop that in. We're going to want to replace that in the part. And the software will recalculate all the information for me in just a few seconds. So as you can see, that way we can easily repeat this inspection anytime we create a new mesh of this part. Okay, so I kind of showed you that here with this similar project, just to show you, again, it kind of covers the process capabilities here as well. Those get calculated for you already when using that statistical trend label. And then creating that project template. So you can access that back under that start menu, project templates that will get saved. Just make sure you have a good view. I guess let me go back in and make sure that I showed that correctly. You're going to want to either load a picture of your part, maybe from your computer, or the 3D view of whatever is happening in your projects. Maybe I just want the GOM block alone, and then we'll say from 3D view. So keeping that CAD in that template allows you to be able to open up the templates and easily see which project you're trying to access so that you can grab it and know that you're bringing in the right corresponding mesh. Okay, and then just to wrap things up, remember that you can always book a demo with our sales team here at Capture 3D if you're interested in the purchase of an ATOS sensor or the professional version of the software. So to summarize what we learned today, we went over that GD&T creation, both in the long way as well as using the quick GD&T menu. We did some custom report pages. Thank you again so much, Wade, for kind of covering how far you can take the free GOM Inspect software within reporting. And then I showed you just a few little things in the professional version just to kind of see what we couldn't do the last couple days to show you that it is possible. And you'll be able to find all the recordings and today's presentation right back in that folder here in this link. So additional training material, if you head to our website, our YouTube channel, using this link here, we have so many videos, helpful videos. Here's a trend analysis one. I'm on there. I have a surface comparison video available for you guys, scan to CAD alignments. We have at least a dozen videos on there, maybe more at this point. We're uploading them pretty frequently. And then the GOM Training Center is also a great resource for you guys to be able to access information directly from the distributor. Okay. Well, great. Thank you guys, everyone, so much for coming these last 3 days, for participating, for asking us your questions. So keep in mind, you'll be able to find this recording back in this folder. Just give us, a little bit of time to be able to upload that for you guys, and then give us about a week or so before you should expect that certificate. And any other questions, you can reach out to that training at capture3d.com.
Thank you, everyone. Glad y'all participated, and hopefully everybody got something good out of it.
Thank you, everybody. Awesome questions and great participation today.